Hi everyone, welcome back. So we were studying about linear algebra and now we are going to study about system of linear equations. So here we are going to study about two kind of equations, homogeneous and non-homogeneous. Homogeneous equations and non-homogeneous equations. Sir, what do you mean by homogeneous equation? What do you mean by non-homogeneous equation? That we will see later on. But as of now, let's focus on what is the meaning of system of linear equation. So forget about this linear word now. First, let me know what is the meaning of system of equations. So let's just say I'm writing down one equation, x1 plus x3 equals to 5. So this is one equation. Then next equation I'm writing down 2x1 plus 3x3 equals to 7. So this is another equation. So this is one equation, this is another equation. If I consider both of the equations together, then it is known as system of equations. What is the meaning of system of equation? Two equations considered together. Two or more than two. Two or more than two. Two or more than two equations considered together. That will be known as system of equations. Understandable? So meaning of system of equation is clear. Now what is the meaning of system of linear equation? Linear means the maximum power of the variable should be 1. What is the maximum power here? 1. What is the maximum power here? Who are the variables here? Variable is x1, x2 and x3. Maximum power 1. Maximum power 1. Maximum power 1. Here also maximum power 1. Here also maximum power 1. Maximum power 1. Maximum power 1 and maximum power 1. And how this could be written? This could be written as 4x1 minus or plus 0x2 minus 2x3, that is equals to 0. So maximum power 1, maximum power 1 and maximum power 1. So maximum power of the variable should be 1, then it is known as system of a linear equation. Understandable? So this is a system of equation and it is system of linear equation as well. So this is system of linear equation. This is also system of linear equation. This is also system of linear equation and this is also system of linear equation. Understandable? So on the left hand side we have written variables. This is the variable and then there is a constant value. Variable, then constant value. Variable and then constant value. Right? Variable, constant value. Variable, constant value. Right? So this is how we have written down the equation. Now if your constant value is 0, if your constant value is always 0, then it is known as homogeneous equation. Homogeneous equation. It is a system of linear equation. All A, B, C, D, they are a system of linear equation. If the constant value is always 0, then it is known as homogeneous. And let's just say, in this example, if this was the condition. Now let me know, is the constant value always 0? No, constant value is 2, minus 4 and 0. It is not always 0. So if it is not always 0, then it is known as non-homogeneous. What do you think? What will be the scenario here? Is it homogeneous or non-homogeneous? It is, sir, non-homogeneous. What about this one? This is homogeneous, right? Because constant value is always 0. Constant value is always 0. Understandable? Is that clear? So did you understand the meaning of system of linear equation? Yes, sir. What is the meaning of system of equation? Two or more than two equations considered together is known as system of equations. What is the meaning of system of linear equation? Linear equation means the maximum power of the variable is 1. That is the meaning of system of linear equation. What do you mean by homogeneous? The constant value should be always 0. And if the constant value is not always 0, then it will be non-homogeneous. So is this slide clear? So if in the examination it is written system of a homogeneous linear equation, will you be able to understand? Yes, sir. System of a homogeneous linear equation. Linear means maximum power 1. Homogeneous means all the constant value 0. That's it. System of non-homogeneous linear equation. Linear equation means maximum power 1. Non-homogeneous means constant value could be either 0 or non-zero. Basically, one of the constant value should be non-zero. That's it. Understandable? Now let's see the matrix representation of our system of equation. So this is a system of linear equation. This is also a system of linear equation. How do I present it in terms of matrix? So I am doing something and you will let me know is it correct or not. So these equations I am going to write down in this manner. In what manner, sir? In this manner. You will let me know, sir, is it correct or not? And if it is correct, then how it is correct? Can I write down these equations somewhat like this? I have made 3 matrices and here I am going to write down 2, minus 5, 3, x1, x2, x3. What is the order here? Order is, sir, 3 cross 1. Next time I am going to write down 4. This 4x1 minus 2x3. That could be written as 4x1 plus 0x2 minus 2x3 equals to minus 4. So 4, 0, minus 2. And minus 3, 4, minus 1. And here I am writing down 2, minus 4 and 1. Let me know is it correct or not. What is the order here? 3 cross 3. So if you multiply both of these matrices, this is the multiplication. Multiplication of this matrix, let's just call this matrix as matrix A. Let's call this matrix as matrix X. And let's call this matrix as matrix B. Okay. So if you multiply matrix A with X, what you will get? 2 into x1, 2x1 minus 5x2 plus 3x3 equals to 2. Basically, do the multiplication of A and X. If you do the multiplication of A and X, what you will be getting? So what will be the order? 3 cross 3 multiplied with 3 cross 1. Order will be 3 cross 1. That means 3 rows would be there and 1 column would be there. So what you will be getting? 2 multiplied with x1, 2x1, minus 5 multiplied with x2, minus 5x2, 3 multiplied with x3, plus 3x3. Then 4x1, 0 multiplied with x2 will be 0, minus 2x3. Then minus 3x1, 4x2, minus x3. That would be equated to what? 2 minus 4, 1. So 2x1 minus, and both are equal matrix, no? Both are equal. That means 2x1 minus 5x2 plus 3x3 would be equated to 2. 2x1 minus 5x2 plus 3x3 would be equated to 2. Then 4x1 minus 2x3 would be equated to minus 4. 4x1 minus 2x3 would be equated to minus 4. Minus 3x1 plus 4x2 minus x3 would be equated to 1. Minus 3x1 plus 4x2 minus x3 would be equated to 1. There you go. So this is the way of writing down the equation in the matrix form. Is that understandable to you or not? So can you write it down? Can you write down this equation on your own? Yes, sir. Surely I can write down this equation on my own. So there are 3 variables here. And sir, and this is how, sir, I'm going to write it down. So 2 equations are given and 3 variables are there. Sir, what all variables are there? Sir, x1 is there, x2 is there, and x3 is there. That would be equated to something. So let's write down. So first equation is 2x1 minus 4x2 plus 6x3. 2x1 minus 4x2 plus 6x3 would be equated to 1. And the second one is, sir, 3x1 plus 0x2 minus 2x3. 3x1 plus 0x2 minus 2x3, that would be equated to 2. There you go. So 2 rows, 3 columns, 3 rows, 1 column, and this would be, what is the order here? 3 rows, 1 column, 3 cross 1, and here what will be the equivalent order? 2 rows, 1 column. So 2 cross 3 multiply with 3 cross 1, so 2 cross 1. So are you able to write down the equations? Yes, sir. Very easily we are able to write down the equations. Understandable? Okay, so here only 2 rows would be there because there are only 2 equations. 3 variables, 2 equations. Understandable? So what you will say? This is your matrix A, this is your matrix X, and this is your matrix B. Understandable? So this A is known as coefficient matrix. Coefficient matrix. Okay. This X is known as variable matrix. And this B is known as constant matrix. Because they are the coefficient, no? Coefficient of x1 is 2, coefficient of x2 is minus 4, coefficient of x3 is 6. So this is the coefficient matrix, X is the variable matrix, and this is your constant matrix. Constant matrix. You don't need to mug up the names, so you will be able to remember it, because in the questions again and again would be written that this is your constant matrix, this is your variable matrix, this is your coefficient matrix. So again and again these names would come up, so you would be able to remember. Don't worry about it. So this is the matrix representation of a set of a linear equation. Will you be able to write down the matrix representation or not? Yes, sir. Very easily I will be able to write down the matrix representation. This I can call as matrix A. This I can call as matrix B. Matrix A, matrix B. So equation is written in terms of AX equals to B. Now if I write down one thing, that if B is a null matrix and if B is not a null matrix, can you let me know if B is a null matrix, then what will be the name of equation? If B is null matrix, B are these coefficient 2, minus 4, 1. I should not say coefficient, these constant value 2, minus 4, 1, 1, 2, 1, 2, 2, minus 4, 1, 1, 2, 1, 2. So if they are 0, if they are all 0, then what do we call it? We call it a homogeneous equation. And if they are non-zero, like it might happen that this is 0. So will I call it null matrix? No, this will not be null matrix. No, even if I make both of them 0, will I call it null matrix? No, because one of the element is non-zero. No, So I will not call it null matrix, right? So it will be a non-null matrix. So it is known as non-homogeneous equation. Understandable? So in case of homogeneous equation, I will simply write down Ax equals to 0. And in case of non-homogeneous equation, I will write down Ax equals to B. Right? In case of homogeneous, I can simply write down Ax equals to 0 because B is 0 only. So that would be Ax equals to 0. So did you understand the meaning of homogeneous equation, non-homogeneous equation, and matrix representation of system of linear equation, whether it is homogeneous or non-homogeneous? So these two slides are absolutely crystal clear to you. So these are the terms that will be used again and again. People will study the whole linear algebra, but if I ask them what is homogeneous equation, they will not even remember it. So system of homogeneous equation, system of non-homogeneous linear equation, everything is crystal clear. How to do the matrix representation, that is also clear. Okay, let's solve some mathematics. Simple mathematical question I am asking you. Have you solved these kind of equations in your life? Yes, sir. In our class 9th, 10th only we used to solve these kind of equations. So can you solve these equations for me? Only task is you need to solve these equations. This is equation 1, this is equation 2, and this is equation 3. You just need to solve these equations, nothing else. And let me know the value of x1, x2, x3. So you need to write down the value in this manner. First, let me know, is it in the form of Ax equals to B? Yes, sir. Why is it in the form of Ax equals to B? Here only we saw it, right? So you need to write down the answer in this manner, that x1, x2, x3. You will get some value of x1, x2, x3, no? Right? You will get some values of x1, x2, x3. So you need to write down in this manner, that these will be the values of x1, x2, x3. So write down your final answer in this manner. Is it fine for you? Yes, sir. I will be able to write down the final answer. So let's solve this equation. So what I am doing is that I will do the twice of equation 1 and then subtract it from equation 2. Right? So what I will get? I am doing twice of equation 1 and then subtract it from equation 2. So this is equation 2 twice of equation 1. So what I will get? 2x1, 2x1, this will be gone. This will be x2 plus x2 minus x3. That would be equated to minus 1. Understandable? Right? So this is another equation I am getting. Let's just say this is equation 4. And then I am having another equation which is x1 plus 2x2 plus x3 plus 3x3. You simply need to solve these equations, nothing else. I don't know why I am explaining it. I don't even need to explain it, right? So what I would do here, I can replace x2 as 1 minus x3. 1 minus x3. Then in x1, x3, I will get an equation. Then from there, I can get the values. So you do it on your own. Okay. So this is what we are getting. Then this x2 minus x3, can I do anything in a faster manner? So let's replace x3 minus 1. In place of x2, let's replace x3 minus 1. So x3 minus 1. So 2x3 minus 2 plus 3x3 equals to 14. So from here what we are getting, that is x1 plus 5x3 equals to 16. This is what we are getting, right? Then what we can do is that now we can replace the value of so from here we were getting the relation that x1 is x2 is x3 minus 1. So x2 is x3 minus 1. This is what we were getting, right? So this equation we have got, this equation we have got. So here we have got that x1 is nothing but 16 minus 5x3. x1 is nothing but 16 minus 5x3. 16 minus 5x3. 16 minus 5x3. Right? So equation 4 and 5 we have got. Now what I do is that I write down the value of x1 and x2 in equation 1. So now I am using equation 1. So in place of x1 what I will put? 16 minus 5x3. Okay. In place of x2 what I will put? x3 minus 1. And in place of x3 I will put x3 only. That is equated to 6. So what answer I will get? This will become 15 and this will become minus 3x3. Right? Minus 5x3 plus x3 plus x3 minus 3x3. 16 minus 1 is 15 and this goes here. This will become minus 9. So x3 value is coming out to be 3. Okay. I am taking too much time, right? x3 value is coming out to be 3. Then if it is 3, then I guess this could be 2, this could be 1. right? 3, 2, 1, 6 and 1. I guess 3, 2, 1 would work. 1, 2 plus 4 plus 9. Yes. And here 1, 2, 6, 6 plus 2, 8, and this is 3. Yeah. So you can solve the equations. Eventually you are getting the answer that x1 is coming out to be 1, x2 is coming out to be 2, and x3 is coming out to be 3. These are the answers we are getting. So when you solve the equations, this is the answer you will get. I just used my intuition that if x3 is coming out to be 3, then here I can put 2 and 1. Then I've checked that yes, equation is being satisfied. So this is the answer we are getting after solving the equation. I hope you can solve the equation on your own. Very simple thing, right? Then you can substitute this x3 value in this equation. What you will get? X1 plus x2, x1 plus x2, and I'm substituting the value of x3 here. So x1 plus x2 will come out to be 3, right? Then if I substitute this value in this equation, or in this equation if I substitute, then I'm getting x1 plus 2x2. What is the value of 3x3? That would be 9. That is coming out to be 5. So if I subtract both of these equations from here, I can see that x2 value I am getting as 2. So x2 value I am getting as 2. Now if you know the value of x2, then from here, from this equation, you can get the value of x1 as well. That is coming out to be 1. Okay. So x1, x2, x3 value we are getting. The important part is this is a unique solution. What I will call it? Unique solution. Unique solution. There is another name of unique solution. Unique solution means trivial solution. What is the other name? Other name is trivial solution. Trivial solution. So here you are getting unique values of x1, x2, x3. The x1 can take only value to be 1. x2 can take only value to be 2. And x3 can take only value to be 3. So x1, x2, x3 can take unique values. Right? So x1, x2, x3 all are dependent solution. Can I say? x1, x2, x3 all are dependent solution. They are not free variables. Can I say x1, x2, x3 are not free variables? What is the meaning of free variable? That x3 is a free variable. What is the meaning of it? That x3 can take any value. x3 can take value 2 as well, 5 as well, 7 as well, 9 as well. But here they are not free. x3 has to take value 3. x2 has to take value 1. Sorry, x2 has to take value 2. And x1 has to take value 1. So they are not free. Right? They are dependent. x2 is dependent. x1 is dependent that it needs to take value 1 only. x2 is dependent that it needs to take value 2 only. And x3 needs to take the value 3 only. So although all these things we will see later on, but as of now you can see that there are no free variables. All are having a certain fixed value. x3 is having fixed value, x2 is having fixed value, x1 is having fixed value. And there is a unique solution. x1 can take only value 1, x2 can take only value 2, and x3 can take only value 3. So there is a unique solution, or you call it trivial solution. Is that understandable to you or not? Okay. Now let's do the matrix representation of this particular scenario. What will be the matrix representation? Sir, 1, 1, 1, 6, 2, 3, 1, 1, 2, 3, and 6, 11, 14. So can you do the matrix representation in this manner? Yes, sir. Very easily I can do the matrix representation. Okay. Now I am making another matrix that is known as, this is your matrix A, this is your matrix B, and this is your matrix X. Now I am making another matrix which is known as augmented matrix. What I am calling? Augmented matrix. I am making a augmented matrix which is A augmented B. Sir, what is the meaning of this? You will write down the matrix in this manner: A augmented B. 1, 1, 1, augmented 6, 2, 3, 1, augmented 11, and 1, 2, 3, augmented 14. Sir, what is the meaning of this sign? There is no meaning of this sign. Basically, it is saying that this is equation, this was the part of matrix A. This particular scenario was the part of matrix A, and this was the part of B. That's it. So you treat this A augmented B as a new matrix C. It is nothing but a new matrix C. Are you able to understand this point? Like, forget about this sign. There is nothing. You will treat this as a new matrix C only. Forget about this particular sign. Is that clear to you? Okay. So new matrix, what is your new matrix C? Your new matrix C is nothing but let me add a page. Your new matrix C, which was given as A augmented B, it is nothing but, forget about this sign. Forget about this particular sign. This is just telling that this was the part of A, This was the part of A and this was the part of B, nothing else. So treat this as a new matrix C and let me know the rank of this matrix. What is the rank? Okay, you need to find out the rank here. What you will find out? You will find out the rank on your own. So how will you find out the rank of this matrix? Again, you need to make row echelon form. So make the row echelon form. How will you make the row echelon form? So I know that I will subtract that twice of it. Whatever the operations you need to apply it on your own. We have seen a lot of examples. Okay. Again and again, I'm not going to do it for you. You guys are good enough now. You can, without writing down the operations, you will be able to find out the rank of this matrix. Okay. So what we are doing next? Let's just copy it once. Yeah. So what we are doing, twice of this I can subtract. So what I will be getting, 0 here I will be getting. Why I'm subtracting that twice, then you would know. Twice of this will give me 1. Twice of this will give me -1, and twice of this will also give me -1. Why I'm subtracting twice of this? I hope you know it. This will be 0, this will be 1, and this will be -1, and this will also be -1. And then simply I will subtract these equations. What I will get? This is 0. Then 2 minus 1 will be 1. 3 minus 1 will be 2, and 14 minus 6 would be 8. What we are doing is that, I hope you understand what we are doing, that your R2 is being replaced with R2 minus R1. And what is R3 is being replaced with? R3 is being replaced with R3 minus R1. Sorry, R2 is being replaced with R2 minus 2R1. Why 2R1? Because twice of this will give me 0. Now next what I will do? Next, simply I know that what I will do is that R3 will be replaced with R3 minus R2. Say yes or no? Absolutely, sir. Why is that so? R1 remains as it is, R2 remains as it is. What was your R2? R2 was 0, 1, -1, and -1. And next, this will change. So R3 is being replaced with R3 minus R2. So 0 minus 0 will be 0, 1 minus 0 will be 0, 2 minus -1 will be 3, and this will become 9. There you go. So is it in the row echelon form? Our first target is that this our matrix C should come in row echelon form. Yes, sir, it is coming in row echelon form. Now you will let me know what is the rank of A. First, you need to get the row echelon form without even thinking of this particular sign. Then once we have got the row echelon form, yes, sir, we have got the row echelon form. After getting the row echelon form, you will tell me rank of A, and this is your A augmented B. So you need to tell me two things. What is the rank of A? So rank of A is coming out to be 3, right? No non-zero row is there, no? Sorry, all 3 rows are non-zero. All 3 rows are non-zero. So rank of A is coming out to be 3. And what is the rank of A augmented B? Rank of A augmented B is also coming out to be 3 only. A augmented B is new matrix C. You don't need to see at this particular sign. Okay, forget about this sign. So what will be the rank? If we forget about this sign, what will be the rank? Sir, all 3 are non-zero rows. 1 1 1 1 6, 0 1 minus 1 1, 0 0 3 9. All 3 are non-zero rows. So what is the rank? 3. So what do you see here? Rank of A is coming out to be rank of A augmented B, and that is coming out to be equals to the number of, that is coming out to be equals to 3, and 3 is nothing but number of variables. Number of variables. Is that clear to you or not? Rank of A is coming out to be equals to rank of A augmented B, and that is nothing but equals to number of variables. Along with that, we know that it is representing a unique solution. Sir, why we are doing all this process, you will understand. Have some patience. Okay, you will understand all this process, why all this process was done. But what did you understand? That we created a new A augmented B matrix. Then we forget about this augmented sign. Our first task was that to get the row echelon form. Once we have got the row echelon form, we go to know that rank of A is coming out to be 3. Rank of A augmented B is also coming out to be 3. Both are equal, and they are equal to the number of variables. Okay, and this is representing unique solution. We will write down all the conclusions, but have some patience. What was the unique solution? Here, this was the unique solution, no? X1 was 1, X2 was 2, X3 was 3. Now, whatever the last matrix we got, this is the last matrix we got, no? So let's talk about this particular matrix, that what we got in the last. This is something that we got in the last. So let me add a page and copy this matrix here. And this is what we got in the last. And you know one thing. What do you know? Sir, this was the matrix A part and this was the B part. Can I write down it again? Can I write down this equation again? Ax equals to B. Whatever the process that we have done, this was the A part, although it is not equivalent to matrix A. This is not equal to matrix A, but it is equivalent to matrix A, no? What I mean to say is that when I said that when we go to the row echelon form, when we apply these transformation, then these matrices are equivalent. These matrices are equivalent, right? These matrices are equivalent of each other. What they are? They are equivalent of each other. Equivalent, right? So this was matrix A. Now whatever the matrix that we have got here, this matrix and this matrix are equivalent of each other. So again, I'm writing down this form that, sir, this particular part was your matrix A. How much part was your matrix A? This much part was your matrix A. Then, sir, it was multiplied with the variable matrix x1, x2, x3. x1, x2, x3. Then it was multiplied with the variable matrix x1, x2, x3. And then the resultant is 6 minus 1, 9. 6 minus 1, 9. 6 minus 1, 9. 6 minus 1, 9. So from here, what you will get? x1 plus x2 plus x3. What you will get? 1 multiply with x1 plus 1 multiply with x2 plus 1 multiply with x3. That is equals to 6. 0 multiply with x1, 0. x2 multiply with 1 minus 1 multiply with x3 minus x3. That is equals to minus 1. 0 multiply with x1, 0. 0 multiply with x2, 0. 3x3. 3 multiply with x3, 3x3. That is equals to 9. If you solve this one, what you are getting? x3 equals to 3. If you put this x3 here, if you put this x3 in this equation, then x3 you will put here. What you are getting? x2 equals to 2. And if you put both of these values, if you put both of these values in this equation, then 3 plus 2 x1 value I will get as 1. Are we getting the same answer? Absolutely, sir. So after applying all these elementary transformation, whatever the row echelon form that we are getting, after applying all the transformation, whatever the row echelon form that we are getting, from this row echelon form, we can recreate our equations. Is that understandable to you? And it is the same thing, no? When we solve this equation, let's solve these equations again. Okay? What I am doing this time? I am solving this equation again. What I am doing? That from this equation 2, I am subtracting twice of equation 1. What I will get? From the equation 2, I am subtracting twice of equation 1. What I will get? x2 minus x3 equals to minus 1. Along with that, next what I am doing? From equation 3, I am subtracting equation 1. From equation 3, I am subtracting equation 1. What I will get? x2 plus 2x3, that is equivalent to 16 minus 14 minus 6 will be 8. So new equations I got, equation 4 and equation 5, and equation 1 is as it is. Now what I am doing is that from equation 5, I am subtracting, from equation 5, I am subtracting equation 4. So what I will get? From equation 5, I am subtracting equation 4. So what I will get? 2x3 minus x3. So this will become 3x3. That will be equivalent to x8 minus of minus 1. That will be 9. So this is the equation 6 I am getting. So let's take up the equations. First, let's take up the equation 1. What was the equation 1? x1 plus x2 plus x3. That is equals to 6. This is one of the equation. Then another equation, let's take up another equation. Let's just say which equation we will take. Yeah. Let's take this equation x2 minus x3. x2 minus x3 equals to minus 1. And then take sixth equation, which is 3x3 equals to 9. So these three equations we are getting, right? Are they the same equation? x1 plus x2 plus x3 equals to 6. x2 minus x3 equals to minus 1. 3x3 equals to 9. x1 plus x2 plus x3 equals to 6. x2 minus x3 equals to minus 1. 3x3 equals to 9. Yes, they are the same equations. So did you understand what is row echelon form? Like how the concept of row echelon form came into action? Whatever the linear operation that we apply to solve a particular equation, the same kind of operation we apply to get the row echelon form as well. And eventually we have got this form, and eventually from this particular form, I can make my equations again. And when I make my equations again, I'm getting the same equations only. These equations and these equations, they are the same only, no? I hope you understand. This set of equation and this set of equation both are same. Here I got it through the row echelon form. And here I got it through simple things. In row 2, I am subtracting twice of row 1. This is nothing but in row 2, I am subtracting twice of row 1. And here in row 3, I am subtracting row 1. And then what I have got? 5 minus 4. That means from row 3, I am subtracting row 2. These operations only I have applied. If you see here, these operations only. This operation, and this operation. The same operation I have applied here. The same operation. Did two same operation. And then I go to know that all are giving me certain values. X3 is giving me value 3, X2 is giving me value 2, and X1 is giving me value 1. Unique solutions are there. They are giving me unique solution, or you can call it trivial solution. Understandable? All these things you will relate, but have some patience. Whatever that I am teaching, just understand that yes, this is what we can do. Here we can form the row echelon form as well, and from the row echelon form as well, we are getting the equivalent matrices. And I go to know that rank of A is coming out to be rank of A augmented B, and that is equals to 3 only. Understandable? And 3 is the number of variables, nothing else. Number of variables. What is 3? 3 is nothing but the number of variables, x1, x2, x3. Then it is representing unique solution. Let's solve another question. When we solve 3 questions, after that complete picture will be clear to you. 3 questions we need to solve. Let's solve this one. Can we solve it now? Okay. So x1 plus x2 plus x3 equals to 3 is given. 2x1 plus x2 plus 2x3 is equals to 6. This is equation 1. This is equation 2. And this is equation 3. Okay. So first of all, what I am doing is that from equation 2, I am subtracting twice of equation 1. What I am getting? From equation 2, I am subtracting twice of equation 1. What I will get? Twice of equation 1. 2x1. This is your equation 2. And what will be the twice of equation 1? That would be 2x1 plus 2x2 plus 2x3 equals to 6. So 6 minus 6 will be 0. So will you get 0 equals to 0? Yes, sir, I will get this equation only, no? From equation 2, if I subtract twice of equation 1, what I will get? 0 equals to 0, which is always true. So nothing fruitful I am getting as of now. As of now, I am not getting anything fruitful, that it is always true, sir. So let's do another thing. What I am doing? From equation 3, I am subtracting equation 1. Basically, both of the equations are same only, no? If you look closely, x1 plus x2 plus x3, that is equals to 3. And another equation is if I take 2 common from here. If I take 2 common from here, then 2 will come common. 6 divided by 2, that what that will be? That will be 3 only. So both equations are same. Both are same equations only. They are same equation. And this is a different equation. This is x1 minus x2 plus x3 equals to 1. So what I am doing is that from equation 3, I am subtracting equation 1. So what I am getting is that I will get minus 2x2 equals to minus 2. So x2 value I am getting as 1. I hope you know how to subtract the equation. x1 will be gone, minus x2, minus x2, that will become minus 2x2, x3 will be gone, and 1 minus 3 will become minus 2. So x2 value you are getting as 1. So if x2 value I am getting as 1, so if I put in this equation, let's call this as equation 4. If I put this value in this equation, then what I am getting? x1 plus 1 plus x3 equals to 3. So x1 plus x3 is coming out to be 2. Now, can you get the value of x1 and x3? Basically, x2 value is fixed. Now, if I say, if I keep x1 as 1 and x3 as 1, then also all the equations will be satisfied. Try doing it. x1 is 1, x3 is 1, and x2 is already 1. So put 1, 1, 1 here. 1 plus 1 plus 1 is 3. 1, 2 plus 2 plus 2 is 6. 1 minus 1 will be 0, plus 1 will be 1. So this equation is also satisfying. This is the correct solution. If I put x1 equals to 0 and x3 equals to 2, because if x1 is 0, then x3 will be 2. And x2 is fixed, which is 1. So if I put x2 equals to 1 here, x3 equals to 2 here, what I will get? 1 plus 2 equals to 3. x1 is 0. x1 is 0. Put 2 here. 2 into 2, 4. 2 into 1, 2. 2 plus 4, 6. Then put x3 equals to 2 here and x1 equals to 1 here. 2 minus 1 will be 1. So this condition is also satisfied. What if I do x1 equals to 2 and x3 equals to 0 and x2 equals to 1? Put these values in these equations, all the equations will be satisfied. What if I do, let's take x1 equals to minus 1. If I take x1 equals to minus 1, then what will be the value of x3? x3 will be 3 and x2 equals to 1, which is fixed. So this will also be satisfied. Put x1 equals to minus 1 here. Minus 1 plus 3 will be 2. 2 plus 1 will be 3. Put again here. So 3 into 2 will be 6. And 2 into 1 will be 1. 2 into minus 1 will be minus 2. So minus 2 minus 2 will minus 2 plus 2 will get cancelled out. 6 equals to 6. And put x1 equals to minus 1 here. X2 equals to x1 equals to minus 1. x2 equals to 1. So minus 1 will become minus 2. Minus 2 plus 3 will become 1. So this condition is also satisfied. So there would be infinite solutions, no? Basically, what I mean to say is that from here, if I say that if I put the value of x3 equals to t, then value of x1 will be nothing but a 2 minus t. So if I write down the solution, vector, this is known as solution vector. So if I write down the solution vector, will the solution vector be somewhat like this? The solution vector is coming out to be somewhat like this, that x3 is t. If x3 is t, then x1 is 2 minus t. And x2 is fixed at 1. So this is the solution that you are getting. And how many number of solutions you are getting? You are getting infinite solutions. Infinite solutions. And what is the meaning of infinite solution? Infinite solutions means non-trivial solution. So for this system of a linear equation, what we are getting infinite solutions. Is that correct or not? What we are getting infinite number of solutions. 1, 1, 1, correct. 0, 1, 2, correct. 2, 1, 0, correct. Minus 1, 1, 3, that is also correct. Put any value of t and you will get the correct answer. Let me know how many free variables are there. How many free variables are there? Free variables. That who is free? If I say x3 is free, I can put any value of x3. So will x1 be also free? No. x1 is depending on x3, no? If I say x3 is 2, then for sure x1 has to be 0 and x2 is already fixed. This is already fixed. This is already fixed. If I say I can put any value of x3, then x1 is fixed. Or if I say I can put any value of x1, if I say x1 is 1, if I say x1 is 1, then x3 has to be 1. So how many number of free variables are there? Can you let me know number of free variables? Number of free variables. So that would be equivalent to 1 only. Only one free variable is there. Say yes or no? Because if I say x3 is free, I can put any value of x3. Then x1 has to be fixed and x2 is already fixed. So number of free variables is only 1. Is that clear to you? And number of free variables means number of independent solution. Number of independent solution. Number of independent solution. What do you mean by number of independent solution? x3 is independent, no? x3 is independent. Any value you can take. x3 will say I am not depending on anyone. I can take any value. I can take value 2, 3, 4, 5, 6. Any value I can take. But x1 will say that I am depending on x3. And what x2 will say? I am already fixed. That means I am depending on value 1. So who is independent? This guy is independent. x3 will say I am independent. I can take any value. Whatever the value you want, you can give me that value. So x3 is independent. And if x3 is independent, then x1 is depending on x3. And x2 is already dependent because it can take only fixed value. So number of independent solution or number of free variables are 1 only. So from this particular equation, set of equation, what is the conclusion you can make? Sir, this set of equation is having infinite solution. Fine. This set of equation are having infinite solutions. And infinite solutions means we can call it non-trivial solution. Along with that, it is having one free variable. Let's make the augmented matrix and everything. Okay. What we are going to do? We are going to make the augmented matrix and all those scenarios. So this is our matrix representation, right? Can I make my augmented matrix now? A augmented B. Can I make the matrix? What will be your task? That treat it as a single matrix and find out their row echelon form. The first task would be that find out their row echelon form. Forget about anything else. Just find out their row echelon form. 1, 1, 1. 3, 6, right? So transformations, I can directly see which kind of a transformation I will apply. Very easily I can see that first transformation I'm going to apply is that R2 will be replaced with R2 minus 2R1. So all 0 row I will be getting, and then R3 will be replaced with simply R3 minus R1. And then I will have to interchange the rows, right? Only the row operation we need to apply. I hope you remember it. Only which operation we will apply? Only the row operations we will apply. So R1 is not getting changed. R1 is as it is. Forget about this ratio sign. Forget about this sign. What you need to do, treat it as a single matrix and find out the row echelon form. This is the first task. Find out the row echelon form. Once we have find out the row echelon form, after that we will think something. So this will be 0, 0, 0, 0, and this will become 0, minus 2, 0, and minus 2. Right? And now I know that I can interchange the rows. So R2 will be interchanged with R3. Right? So after interchanging, what I will be getting, this is the matrix I will be getting. And it will be in the row echelon form. So 1, 1, 1, 1, 1, 3, 0, minus 2, 0, minus 2, 0, 0, 0, and 0. What was this? This was your matrix A. What was this? This was your matrix A augmented B. Let me know one thing. What is the rank of A here? So that is coming out to be 2. Rank of A. Rank of A. Only this much matrix you need to consider. So how many non-zero rows are there? 2 non-zero rows are there. Rank of A is coming out to be 2. What is rank of A augmented B? This much you need to consider. A augmented B. How many non-zero rows are there? Forget about this sign now. A augmented B is a new matrix, right? So forget about this sign. Let me know how many non-zero rows are there. Sir, 1, 1, 1, 1, 3 non-zero row, 0, minus 2, 0, minus 2 non-zero row, and this is all 0 row. So what is the rank of A augmented B? That is also 2. So what conclusion you are making from here? The conclusion, first of all, this is the scenario. The conclusion is that rank of A is coming out to be equals to rank of A augmented B only. That is equals to 2, which is less than the number of variables. What is number of variables? Number of variables are 3, no? What is the number of variables? Number of variables are 3. So 2 is less than 3, right? So this is the scenario we are getting, that rank of A equals to rank of A augmented B, but that is less than the number of variables, which is representing infinite solutions. Can you get infinite solutions from here? Yes, sir. Can you make the equations? This is minus 2. This line will be of x2, right? That is coming out to be minus 2. This equation I will get from here. I will get the value of x2 equals to 1. And then x1 plus x2 plus x3 equals to 3. I hope you know what I am talking about. You take this matrix outward, the similar process that we did here. The similar process. After getting the row echelon form, I took this matrix outward, x1, x2, x3, 6, minus 1, 9, and then wrote down this equation and then I solved it. So similar scenario here, that take this particular matrix outward, this matrix 1, 1, 1, 0, minus 2, 0, 0, 0, 0, multiply with x1, x2, and x3, and that then equate it to 3, minus 2, and 0. So what you will get, 0x1 plus 0x2 plus 0x3 equals to 0, 0x1 minus 2x2 minus 2x2, 0x3 equals to minus 2. So from here x2 value you will get as 1, and then x1 plus x2 plus x3 equals to 3. Then from there you will get to know that x1 plus x3 is coming out to be 2. So this is the solution you will get. So again you would know that there are infinite solutions. And what is the meaning of infinite solution? You can call it non-trivial solution as well. Infinite solution means non-trivial. Non-trivial solutions you are getting. Is that understandable to you? So two situations we have seen. In the first situation there was only one unique solution, but here there is infinite solution. Can you find out the nullity of A? Nullity of A. What is the nullity of A? I told you nullity of A is the number of columns. How many number of columns are there? 3. Minus the rank. What is the rank? Rank is 2. What is the nullity? 1. Can you let me know what this 1 is representing? 1 is representing the number of free variables. Although this point we will see again, but yes, here only we can see. What is the nullity? 3 minus 2. So 3 is the number of columns of A. Number of columns of A. And better than remembering number of columns of A, that will be equal to the number of variables. Can you let me know how many columns will be there? They will be equal to the number of variables, no? Like what is the order here? 3 cross 1. If there were 4 variables, then what would have been the order? 4 cross 1, right? If there were 5 variables, what would have been the order? 5 cross 1. Now, if you want to make the multiplication successful, then what should be the order? M cross 5, no? If you want the multiplication to be successful, then order should be M cross 5. That means these two guys should match. So number of variables will always match to the number of columns. So in the last lecture, when I said that the definition of nullity is the number of columns minus the rank. So why I said number of columns? There the actual meaning was not number of columns. There the actual meaning was number of variables. So actual meaning of nullity is number of variables minus the rank. But number of variables will always be equal to the number of column. So that's why the definition comes out to be number of columns minus the number of variable. But actual definition is number of variables minus the rank. Okay, number of variables minus rank. But in theory, what do we write down? Number of columns minus rank. Understandable? All these things we will see it again. But here I am trying to relate the things. Whatever the points that I can deliver, every point I am trying to relate it here. But again, this will come up that what is the actual meaning of nullity. So let's ignore nullity as of now. Nullity we will see later on. Okay, again it will come up. We will see it later on. Yeah. So infinite solutions we have seen. So 2 examples we have seen. One example was having unique solution. Other example was having infinite solution. Let's see the third example. Solve these 3 equations. X1, X2 and X3. I don't need to solve it much. What I can sense is that my first equation is X1 plus X2 plus X3 equals to 3. And the second equation, if I take 2 common, what I will be getting? So I will be getting X1 plus X2 plus X3. 7 divided by 2, what that would be? 3.5. 2 I am taking common. 7 divided by 2 will be 3.5. Is it possible? Is it possible? One equation is saying that X1 plus X2 plus X3 should be equal to 3. Other equation is saying that X1 plus X2 plus X3 should be equal to 3.5. Is it possible? No. Right? It is not possible. Or what you can say is that let's call this as equation 4 and let's call this equation as 5. Subtract 5 from 4. What you will be getting? X1 minus X1 will be 0. X2 minus X2 will be 0. X3 minus X3 will be 0. And 3.5 minus 3 will be 0.5. Is it possible? 0 equals to 0.5. Not possible. What does that mean? No solution exists. No solution exists. Okay, no solution exists. There is another name of this. What is the another name? It is known as inconsistent solution. If there is no solution, that means it is known as inconsistent solution. If you are not consistent in your studies, that means you are not studying at all. So today I am studying 2 hours, then I am studying 7 hours, then I am studying, sir, 3 hours, then I am not studying for 3 days, sir. Then suddenly I am studying 10 hours, then sir, I am studying 1 hour, then sir, again I am not studying, then again studying. If this is the scenario, that means there is no studies at all. You have to be consistent. So if there are no solutions, then there is inconsistent solutions. Is that understandable to you? Inconsistent solution or solution? Inconsistent solution. The same scenario we will do. Matrix representation. Again, A augmented B. Let's see what we get in A augmented B. Let's see what we are getting in A augmented B. Initially, our task would be to get the row echelon form, treating it as a new matrix C. Once we get the row echelon form, we will understand that what it is representing. 2, 2, 2, 7, 1, minus 1, 1, and 1. What operations we are going to apply? Directly I can sense that, sir, I am going to replace R2 with R2 minus 2 R1. Okay, and then I am going to replace R3 with R3 minus R1. And then, sir, I am going to interchange as well. What do I mean? In one step only I am writing down everything. Because I can sense that I will be able to get the row echelon form. After that, only thing I need to do is interchange. What I mean to say is that first one as it is, 1, 1, 1, 3. Then twice of this I am subtracting. So 0, 0, 0 and 1 I am getting here. And then this will be 0. This will be minus 2. This will be 0. And this will be minus 2. So this is the scenario we are getting. Right? And then I need to interchange these two. No? Like this guy goes upward, this comes downward. 0, 0, 1 comes downward. After that I will interchange. R2 interchange with R3. So directly I am writing in this step only. Because what will row echelon form will say that here, what is the first non-zero element? This is the first non-zero element. Here, what is the first non-zero element? This is the first non-zero element. First non-zero element. So how many number of zeros? 0. How many number of zeros? 3. How many number of zeros? 1. So 0, 3, 1, not a row echelon form. So this goes upward, other one goes downward. So already I am replacing it. Okay. So what I am doing is that in the last I will get 0, 0, 0, 1. And here I will be getting minus 2, minus 2. Minus 2, minus 2. So interchange also I have done. So number of zeros, here number of zeros before the first non-zero element is 1. Here number of zeros before the first non-zero element is 3. Right? Now this is our A and this is our A augmented B. Understandable? Let me know what is the rank of A. Rank of A is 2 only. What is rank of A? You need to consider only this much part. Only this much part. In this much part, you let me know how many non-zero rows are there. How many non-zero rows are there? First and second. So rank of A is 2. Think about it carefully and let me know what is the rank of A augmented B. What is the rank of A augmented B? This is A augmented B. How many non-zero rows are there? First row is non-zero, second row is non-zero, third row is also non-zero. 0, 0, 0, 1. A augmented B. A augmented B is this much. This is your A and this is your A augmented B. So what is the rank of A augmented B? That is 3. If rank of A is not coming out to be equals to rank of A augmented B, then what it is representing? It is representing no solution. Is that clear to you? Why it is representing no solution? Can you think? Can you understand the meaning of last line? 0, 0, 0, 1. If I make the matrix form, what I will get? 0, 0, 0. Multiply with x1, x2, x3. And last element would be 1. So 0 multiply with x1 plus 0 multiply with x2 plus 0 multiply with x3 is giving me 1. Is it possible? Is it possible? From this particular line, from this line, what I have got? 0 dot x1 plus 0 dot x2 plus 0 dot x3 equals to 1. Is it possible? Not possible. What does that mean? No solution. So from the last line only I can conclude that. So what does that mean? Here we are having 0 row, 0, 0, 0. Here we are having 0 row, but here we are having non-zero row. In A augmented B, we are having non-zero row, but in matrix A, we are having 0 row. That means the rank of A is not matching with rank of B. Sorry, rank of A is not matching with the rank of A augmented B. What does that mean? It cannot have any solution. No solution will exist. Is that clear to you or not? So 3 conditions we have seen. Let's revisit all the 3 conditions. We started from here. We understood the meaning of a linear equation, homogeneous, non-homogeneous, whatever it was. Then we started solving the first equation. We got to know that we are getting the unique solution, and along with that we saw one more thing, that rank of A is coming out to be equal to rank of A augmented B, and that is equal to the number of variables. That means there will be unique solution. Here what we saw, that rank of A is coming out to be equal to rank of A augmented B, but that is less than the number of variables. Here 3 variables were there, but we are able to get 2 equations. Out of this, if you need to write down the equation, what equations you will get? x1 plus x2 plus x3 equals to 3 minus 2x2 equals to minus 2. So although variables are 3, although they have given us 3 equations, but actually they are 2 equations only. Why they are 2 equations only? Because this equation and this equation is same. So they have given us 3 equation, but equivalently we are having only 2 equations. Why is that so? Because this equation is dependent on this equation. If you multiply this equation, if you multiply equation 1 with 2, then you will get the equation 2. If you multiply the equation 1 with constant value 2, then you will get equation 2 only. Are you able to understand this point? So that's why, although they gave us 3 equations, but they were actually 2 equations only. So you are having 2 equations, but 3 variables. 2 equations, but 3 variables. So it is pretty obvious that one of the variable has to be free. Or you can say one of the variable has to be independent. Why is that so? Because you are having 2 equations only and 3 variables are there. So from 2 equations, you can find out the solution of only 2 variables. From 2 equations, you can find out the solution of only 2 variables. If I give you x plus y equals to 1 and x minus y equals to 2. So from these 2 equations, you can find out the value of x and y. If I give you only one equation, x plus 2 equals to 3. So from here, you can find out the value of x only. But if I give you x plus y equals to 3, 2 variables are there, but only one equation. 2 variables, only one equation. So will you be able to let me know the value of x and y independently? No. What you will say, sir, y can take any value. Let's just say y is taking value 1, then x will take value 2. If y is taking value 2, then x will take value 1. If y is taking value 3, then x will take value 0. If y is taking value 4, then x will take value minus 1. In that manner, you will say. So one variable has to be free. So similarly here as well, if we are having 2 equation and 3 variable, then one variable has to be free. So we were having one free variable. Understandable? So everything you can relate with the equations only. You don't need to mug up any results. Okay, 2 equation, 3 variables. Effectively we are having 2 equations and 3 variable. What does that mean? That means that one free variable. Understandable? So this is the second equation we saw, and then this is the third system of equation we saw. Here both of the equations are inconsistent. One is saying it should be equivalent to 3, and another one is saying it is equivalent to 3.5, which is not even possible. So there is no solution, or you can say inconsistent solution is there. And when we go to know about the inconsistent solution, we checked the rank of A and rank of A augmented B. We go to know that both of the ranks are not even equal. If both of the ranks are not even equal, what does that mean? That means there will be no solution. And based on that, let's make a conclusion about the system of non-homogeneous linear equations. Okay, what we were studying about? We were studying about Ax equals to B. As of now, these were non-zero, right? These were non-zero. So we were studying about non-homogeneous equation. That means we were studying about Ax equals to B. So we can have two kind of solution: inconsistent and consistent. What is the meaning of inconsistent solution? Inconsistent solution means no solutions. No solution exists. No solution exists. And what is the condition for that? If there is no solution, what is the condition? Sir, the only condition is that rank of A should not be equals to rank of A augmented B. If both are not same, then no solution exists. What is the meaning of consistent solution? Consistent solution means solution exists. Solution exists. Okay, solution exists. If solutions are existing, then there could be two conditions, no? If solutions are existing, then there could be two conditions. What will be those two conditions? One condition will be infinite solutions. Infinite solutions. And other condition will be unique solution. What is the other name of infinite solution? The other name of infinite solution is non-trivial solution. And what is the other name of unique solution? Trivial solution. Infinite solution and trivial solution. What was the condition for this? First condition is, like, if there is consistent solution, then condition is that rank of A should be equal to rank of A augmented B. If this is the scenario that I am getting, then I will say that consistent solution is there. That means solution would exist. But if rank of A equals to rank A augmented B, and that is less than the number of variables. What is n here? N is the number of variables. Then there will be infinite solution. If rank of A equals to rank A augmented B, but that is equals to the number of variables, then it will have unique solution. So all the conclusion we have seen. What I am saying is that what is n? N is the number of variables. This is the complete table we have made. That's it. There is nothing more to learn in this lecture. If you just remember this table, you will be able to solve all the questions. At least, like every year, one question would be asked from here. System of linear non-homogeneous linear equation. Consistent solution, inconsistent solution. What is the meaning of inconsistent solution? No solution exists. Okay. So there could be only three kind of solution: no solution, or infinite solution, or unique solution. I give you a system of equation and I ask you that the system is having two solutions. Is that correct? No. System can either have one unique solution, or it can have infinite solution, or no solution at all. It can never have two solution, or it can never have three solution, or it can never have four solution, five solution. They are never possible. Either one solution, or infinite solution, or no solution. Only three things are possible. How many solutions are possible? How many solutions are possible? Either zero solution, or one solution only, or infinite solution only. So no solution, unique solution, infinite solution. What is the name of this one? Non-trivial. What is the name of this one? Trivial. And what is the name of this one? Inconsistent. And what is the meaning of consistent? Consistent means both of them would be together considered. That it can have either one solution or it can have infinite solution. Then it would be knowing as consistent solution. If they are saying consistent solution, that means solution would exist. If they are saying inconsistent, no solution exists. Inconsistent, there are two kind of things. Either it can have infinite solution or it can have unique solution. So in a small note, you can write down that possible solutions are number of solutions possible. Solution possible are either no solution or unique solution or infinite solution. Infinite solution. That's it. These three are only possible. Rest, nothing is possible. Understandable? All good? All fine? So this is the table. I hope with proper reasoning you know everything now. Here, if it is less than the number of variables, then you would know that there will be a zero row. If there is a zero row, that means it is pretty obvious that 0 into x1 plus 0 into x2 plus 0 into x3 equals to 0 only. That means, sir, we are having more variables but lesser equation. More variable, lesser equation means, sir, what does that mean? That is simply means, sir, that variables will be free. And if there are free variables, that means surely there will be infinite solution. Here, sir, there will be no free variable. So if there is no free variable, what does that mean, sir? That means there will be only unique solution. And sir, here what will be the condition? That sir, both of the ranks are not matching, then what will happen? If both of the ranks are not matching, then sir, what kind of condition we will get? We will get this kind of condition that 0 into x1 plus 0 into x2 plus 0 into x3 is coming out to be equals to 1, which is not even possible. It is coming out to be equals to non-zero value. It is never possible. What does that mean, sir? It will be no solution. So proper reasoning is clear, and this table is also clear, and it will be stuck in your mind. I hope you understand this. Otherwise, I could have started with this table and I could have solved the problems. But I wanted to give you the intuition first, and now this table is a cakewalk for you. Otherwise, you will keep on remembering trivial solution, non-trivial solution. This is the condition. That is the condition. No, nothing. Close your eyes. Speak with me. Consistent solution, inconsistent solution. Consistent solution means solution would exist. If solution is existing, that means rank of A would be equals to rank of A augmented B. Now there could be two conditions. If rank of A is coming out to be equals to the rank of A augmented B, but that is less than the number of variables. If it is less than the number of variables, that means there will be infinite solution. If it is equals to the number of variables, there will be unique solution. And what about inconsistent solution? No solution would exist. That means rank of A is not even equals to the rank of A augmented B. That is the condition of inconsistent solution. So other names, inconsistent solution. What is the other name of consistent solution? There are two parts, unique solution and infinite solution. What is the other name of unique solution? Unique solution means trivial solution. And what is the name of a infinite solution? The other name is non-trivial solution. So non-trivial, trivial, inconsistent. Names are also clear, conditions are also clear. Everything is crystal clear. Say yes or no. So this was the scenario of our non-homogeneous linear equations. Say yes or no. So next, do we have some questions? Yes. Find the solution and the nature of solution. What do you need to tell? You need to tell the solution of these equations and the nature of the solutions as well. Okay. And tell the number of free variables as well. Tell number of free variables or number of free variables, or what could be the other name? Or number of independent solutions. So how will you solve it? If someone would say that, sir, this is equation 1, this is equation 2, this is equation 3. If I look closely, equation 1, equation 2 and equation 3 are same only. If you take 2 common, what you will get? x1 plus x2 plus x3 equals to 3. If you take 2 common, so 6 divided by 2 will be 3. If you take 3 common, what you will get? x1 plus x2 plus x3 equals to 3. If you take 3 common, so 9 divided by 3 will be 3 only. So equation 1 is same as equation 2 is same as equation 3. That means effectively we are given only one equation. Effectively we are given only this equation only. Effectively only one equation is given. Is that understandable to you? Now in this one equation, x1 plus x2 plus x3 equals to 3. Someone would say that, sir, I will keep the value of x1 equals to 1, x2 equals to 1, then x3 would also be equals to 1. Someone would say that, sir, I will keep the value of x1 equals to 0, x2 equals to 1, then x3 would be equals to 2. Someone would say that, sir, I will keep the value of x1 equals to 2, x2 equals to 0, then x3 will have to be 1. So in that manner, someone would say that, sir, I will keep the value of x1 as c1, x2 as c2, then value of x3 would be 3 minus c1 minus c2. Is that understandable to you? If I keep the value of x1 as c1, x2 as c2, then the value of x3 will be 3 minus c1 minus c2. So what will be my solution vector? x1, x2, x3. Solution vector would look somewhat like this. x1 is c1, x2 is c2, and x3 is 3 minus c1 minus c2. Okay. Tell me the number of free variables. 3 variables are there. 3 variables are there. And one equation is given. 3 variables, one equation. How many free variables are there? Number of free variables. Number of free variables. How many free variables are there? 2 free variables are there, no? For 3 variables, I am given effectively one equation only. So someone would say that, sir, independently I can take the value of x1. Then someone would say, sir, independently I can take the value of x2. Any value of x1 I can take, any value of x2 I can take. But if I take any random value of x1, x2, then x3 will be depending on the values of x1 and x2. Here he was saying x1 is 1, x2 is 1, any random value. Then x3 has to be 1. x1 is 0, x2 is 1, x3 has to be 2. Are you able to understand this point? So similarly, x1 is c1, x2 is c2, then x3 has to be 3 minus c1 minus c2. So number of free variables are 2, or number of independent solutions are 2. Is that understandable to you? They are independent of anyone. Independently you can take any value. Independently you can take any value. But this value will be depending on these c1 and c2. So independent solutions are 2. So this is how mathematically I can solve this question. But what if we need to solve it through matrix form? Then can you make the matrix A? Yes, sir. Can you make the matrix B? Yes, sir. Can you make the matrix A augmented B? Yes, sir. So directly let's make the matrix A augmented B. Directly I am taking. You just need to take the coefficient and then you need to write down the constant value. So 1, 1, 1, 1, 1, 1, 3, 2, 2, 2, 6, right? 2, 2, 2, 6, 3, 3, 3, 9. 3, 3, 3, 9. Very easily you can apply the transformation. First treat A augmented B as a full matrix. Forget about this ratio sign. Simply find out the row echelon form. What will be the row echelon form? R2 being replaced with R2 minus 2R1 and R3 being replaced with R3 minus 3R1. So what is the answer we are getting? The answer we are getting is first one would be 1, 1, 1, 1, 3 and then 0, 0, 0, 0, 0, 0 and 0, 0, 0. So 1, 1, 1, 3, then twice of this 0, 0, 0, 0, then 0, 0, 0, 0. What do we see here? This was your A and this was your A augmented B. So what is the rank of A you are getting? So rank of A, only this much part I need to see. How many number of non-zero rows you are having? Only one. What is the rank of A augmented B you are getting? This much part I need to see. How many number of non-zero rows you are having? Only one. So what do you see here? Rank of A. 1 second. Yeah, sorry for the interruption. So what I was saying, rank of A equals to rank of A augmented B, and that is coming out to be 1. And which is less than the number of variables. Let's write down here. This is coming out to be 1, and it is less than the number of variables. How many number of variables are there? Number of variables are 3. So it is surely less than the number of variables. So what you are getting? This will be consistent solution. 3 names are there. Consistent solution. That means solution would exist. So consistent solution you can say. What could be the other name? Infinite solutions. There will be infinite number of solutions. And what could be the other name? The other name is non-trivial solution. So these 3 names are there. Consistent solution, infinite solution, non-trivial solution. How to find out the number of free variables or number of independent solutions? How to find out that? So what I will do is that I will calculate the nullity of A. What do you mean by nullity of A? Nullity of A would be equals to the number of variables minus the rank of A. So how many number of variables you are having? 3. What is the rank of A? Rank of A is 1. How many number of variables we are having? That is 3. What is the rank of A? Rank of A is 1. So what you are getting? Nullity equals to 2. And what it is representing? It is representing the number of free variables, or you can say number of independent solutions. And why it is representing? Because you know that if nullity is coming out to be 2, that means 2 rows are gone. 2 equations are gone. These equations are gone. If they are having no importance, then only one equation is left. One equation, 3 variables. One equation, 3 variables. That means 2 variables will be free. So all you need to remember is that if they are asking the number of independent solutions or number of free variables, then you need to find out the nullity of matrix A. And how will you find out the nullity of matrix A? First you will calculate the number of variables. Number of variables 3 minus, then you will calculate the rank. Rank is 1. So number of free variables or number of independent solutions. So this is what nullity represents. But sir, in the last video, what did you write down? Nullity definition was number of columns. Yes, what is the number of columns? 1, 2, 3. So another thing I am writing down, number of columns in A. Number of columns in matrix A would be equals to the number of variables. And it is pretty obvious as well. Why it is obvious? I have explained you. How I explained? Using this scenario, here I explained. Right? Because this is 3 cross 1 and what this is 3 cross 3. If you want the multiplication to be successful, then these two guys should be same. That means the number of columns of A should be equal to the number of variables. What is this 3? Number of variables x1, x2, x3. So number of columns of A should be equal to the number of variables. So number of columns of A would always be equal to the number of variables. So although the definition of nullity in books would be written that number of columns minus rank, but actually it is number of variables minus rank. And what that would represent? That would represent the number of free variables. I'm telling you guys, a lot of people will directly remember the results, but here every single intuition is clear. Every single reasoning is clear. You need to remember this table. Every single thing is clear here. In this whole slide, whatever that you have written down, you have intuition of every single thing cleared. So do you need to mug it up? Absolutely not. Right? Do you need to mug up that nullity of A would represent number of independent solution? Will you be doing this thing? No. What you will think? Nullity of A. What it will represent? Nullity of A. So there will be 0 rows. 0 rows means these equations will be cancelled out. So how many effective equation I will be having? Effective equation I am having only 1. So there were 3 variables, 1 effective equation. 3 variable, 1 effective equation. That means 2 free variables would be there. That's it. So what is nullity representing? Free variables or number of independent solution. So how much confident you will be in the examination hall. So this will increase the confidence. If I'm teaching in some crash courses and all, then I will directly write down the results. You remember that result and then solve the questions. But in the comprehensive course, this is the biggest advantage we are having, that we know the reasoning of every single thing. Say yes or no. Okay. Understanding what nullity represents, we have already understood. Just we are going to write down the same thing again and again. What we are doing, have we seen this example? X1 plus X2 plus X2 S3 equals to 3, 2x1 plus 2x2. This example we have seen. Where we have seen? Here we have seen the same example. What was the solution we were getting? 2 minus t, 1t. 2 minus t, 1t. This is the solution we were getting. So 2 minus t, 1t. This is the solution we are getting. X1, X2, X3. This is the solution we were getting. And this was the matrix we were getting. So here, what was the rank of A? That was equals to rank A augmented B. That was equals to 2, which was less than the number of variables. What is the number of variables here? Number of variables are 3. What does that mean? There will be infinite solution. So what will be the nullity? Nullity will be number of variables minus the rank. What that would be? That would come out to be equals to 1. So nullity of A is coming out to be equals to 1, which is showing the number of free variables. How many free variables are there? So this is fixed. If I say this is free, if I say t is free, t can take any value, then 2 minus t will take a value depending on t. If I am saying t is taking value 1, then 2 minus t will take value 1. If I say t is taking value 2, then 2 minus t will take value 0. If I say t is taking value 3, then 2 minus t will take value minus 1. Right? So how many free variables are there? So this is representing the number of free variables, or you can say number of independent solutions, or independent solution. Because this is independent of anyone. This is not depending on anyone. This is free. So this is your free variable. Free variable. This is fixed, and this is dependent. So how many free variables or independent solution you are having? Independent solution. That is represented by the nullity. Okay, let's solve this one. This example also we have seen. This was the answer we were getting. That here what we assumed, here the opposite answer we wrote down. Actually, we assumed that x1 is giving you, if I am taking the value of x1 as c1 and x2 as c2, then value of x3 will be 3 minus c1 minus c2. So this is also free, this is also free. So both are free variables. But this one is dependent. Right? And what about the nullity? Nullity of A. So what will be the nullity of A? So nullity of A would be nothing but the number of variables. How many variables are there? 3. Minus the rank. What is the rank? It's coming out to be, rank is coming out to be 1 only. Rank of A is coming out to be 1 only. What is the answer? 2. This is representing the number of independent solution or number of free variables. Okay. So we already know what nullity represents. Just it is the revision of that. Understandable? Find the number of free variables for the given system. This is the question that is coming in the examination hall. How will you solve it? In the examination hall, this question is coming. How will you solve it? So, sir, what I will do is that I will make A augmented B matrix. Two, 3, minus 1, 1, 3, minus 2, 1, and 2. What I need to do? I need to make row echelon form. So what is something that I need to do is that what I will do, sir, R2 will be replaced with R2 minus, what I will do is that I will multiply R2 with 2 and R1 with 3. Why I am doing so? Because 6 minus 6 will give me 0. Right? So this is what I will be getting. Nature of solution also you need to tell. Will there be infinite solution or anything somewhat like this? Nature of solution also you need to tell. Okay. So 3, 2, 3, minus 1 and 1. So multiply with 2, this will be 6, minus 4, 2 and 4. And then multiply with 3, this will be 6, this will be 9, this will be minus 3 and this will be 3. And you need to subtract. 6 minus 6 will be 0. And minus 13. This will be 5. And this will be 1. So is it in the row echelon form? Yes, sir. It is in the row echelon form for sure. Row echelon form for sure. This was your A and this was your A augmented B. So what is the rank of A is coming out to be? rank of A. How many non-zero rows are there? Non-zero rows, 1 and 2. Two non-zero rows are there. And what is the rank of A augmented B? How many non-zero rows are there? In this scenario, how many non-zero rows are there? 2. Will there be infinite solutions? Or there will be only one solution? It feels like that, sir. There will be only one solution. There is no zero row. Like, sir, when we were taking the condition of infinite solution, here zero rows were coming. Sir, here zero rows were coming. Sir, how there will be infinite solution? There will be infinite solution only. What is the scenario? Rank of A is coming out to be rank of A augmented B. That is less than the number of variables. How many variables are there? X, Y, Z. What is the number of variables? Number of variables. How many number of variables you are getting? 3. So is it less than the number of variables? This is coming out to be equals to. This is coming out to be equals to 2, which is less than the number of variables. Although there is no complete zero row, here there were complete zero row, here there were complete zero row. So eventually what happens is that a lot of students would think that if a complete zero row is coming, no, then only I will say there is infinite solutions. Otherwise I will say there is a unique solution. But here as well there will be infinite solution. Why is that so? Why there are infinite solution? Because number of variables are 3 and effective equations are 2. Number of variables are 3, effective equations are 2. That means one free variable would be there. That shows infinite solutions. Is that understandable to you or not? So effective equations are 2. Number of variables are 3. So one free variable would be there, or you can simply say rank of A is coming out to be 2, rank of A augmented B is also coming out to be 2. Both are same, but the rank is less than the number of variables. 2 is less than 3, and if this is the condition, then what does this condition represent? What does this particular condition represent? This will represent infinite or non-trivial solutions. And let me know the number of free variables. How many number of free variables would be there? Sir, I need to find out the nullity of A. Nullity of A would represent the number of variables. Number of variables will be 3 minus the rank. Rank is 2. That is 1. So this is the number of free variables or number of independent solution. Number of free variables. And if someone would have write down the definition of nullity as number of columns minus the nullity. Sorry, number of columns minus the rank. So how many number of columns are there? 1, 2, 3. So number of columns in A is 3 minus rank. Rank is 2. So number of free variables is always 1. So number of free variables are 1 and effective equations are 2. So there are 2 effective equations having 3 variables. One free variable would be there and the infinite solution would be there. So this is how I will be solving this question. Intuitions are also clear. Method is also clear. You apply the method, write down the rank. If they are coming equal, that means yes, there are consistent solution. Now whether there will be one solution or infinite solution, that you will understand by the number of variables. If there are 3 variables, so rank of A equals to rank of B is less than the number of variables, that means there will be infinite solutions. That's it, or non-trivial solution. Now someone would ask how many free variables are there. So for that you will calculate the nullity of A. Nullity of A means the total number of variables, or you can say total number of columns in A, that will be 3 minus the rank. Rank is 2, so answer is 1. There you go. Understandable? Now we will understand about homogeneous equations. But before this homogeneous equation, I want to ask you one question. Where do I ask? Do we have any space? Before studying about homogeneous equation, I want to ask you a question. Yeah, this space I can take. Let's go down. Chal. Yes. I'm asking this question. Is it possible? Is it possible to get rank of A greater than rank of A augmented B? Is it possible? Rank of A is greater than the rank of A augmented B. Let's make any A augmented B matrix. What we are making? A augmented B. So here this will be the part of A and this will be the part of A augmented B. Let's just say I am taking as rank of A equals to 0. Rank of A equals to 2. So this will be 0, 0, 0, right? And I'm taking rank of A augmented B. I need to write down the rank of A augmented B. So this will be some, let's just say alpha, beta, gamma, neta. This will be 0, A, B, and C, right? So is it in the row echelon form? Yes, it is in the row echelon form. Now this element could be either 0 or non-zero. If it is non-zero, let's just say it is a non-zero element, it is D. Then what is the rank of A augmented B? A augmented B, that will be 3. So rank of A augmented B is greater than rank of A. And what if it is 0? What if it is 0? Then what will be the rank of A augmented B? Sir, that will be 2. That is equal. So sir, again my target was rank of A should be greater. So someone would say that, sir, you keep this as non-zero. You keep this as M. Let me know what is the rank of A here. So rank of A will be 3 non-zero rows are there. So sir, rank of A will become 3. What will be the rank of A augmented B? A augmented B is this whole matrix, no? So what is the first non-zero element? This is the first non-zero element. What is the first non-zero element? This is the first non-zero element. What is the first non-zero element? This is the first non-zero element. Again, this is also non-zero row. This is also non-zero row, and this is also non-zero row. So what is the rank of A augmented B here? That is 3. So can you ever get rank of A greater than the rank of A augmented B? This is the aptitude question. Think about it. If a rank of A I am getting the maximum, let's just say rank of A I am getting as 3. Then by default I know that rank of A augmented B will be 3 only. No, is that clear to you or not? So rank of A can never be greater than rank of A augmented B. So answer is no. What all condition you can get? First condition is that rank of A equals to rank of A augmented B. This is what we can get. Or second condition what we can get? That rank of A is less than rank of A augmented B. Only these two conditions we can get. Can we ever get this condition that rank of A is greater than rank of A augmented B? This is never possible. Never possible. If we are getting this condition, that means there is consistent solution. And if we are getting this condition, that means inconsistent system would be there. Okay, inconsistent system would be there. Although in theory we write down rank of A is not equal to rank of A augmented B, but we know that only one condition is there when they will not be equal. This is never possible. Rank of A can never be greater. Why it can never be greater? Because sir, even if I wanted to make it greater, I made the maximum rank of A. Then what I saw, rank of A augmented B is by default 3. Because this is the first non-zero element, this is also non-zero row. Non-zero row, non-zero row, non-zero row, this is 3. Is that clear to you? Understandable? Now let's study about homogeneous equation. So here what will be the form? Ax equals to b, but you can see constant matrix is 0. So the form will be Ax equals to 0. Can you solve these equations? Can you solve the equations on your own? What I am doing, let's call this as equation 1, this as equation 2, and this as equation 3. Okay. So twice of this I am subtracting. From equation 2, I am subtracting twice of equation 1. What you will get? X2 minus x3 equals to 0. Twice of equation 1. So this will be 2. This is x2 and this is x2 minus x3 equals to 1. And then from equation 3, I will subtract equation 1. So what I will get? X2 plus 2x3 equals to 0. This is equation 4 I am saying. And this is equation 5 I am saying. Now from equation 5, I subtract equation 4. So what you will get? From equation 5, I will subtract equation 4. So I will get 3x3 equals to 0. From here, x3 is coming out to be 0. If x3 is coming out to be 0, if you put x3 equals to 0 here, then what is x2 coming out to be? x2 is also coming out to be 0. And if x2 is 0, x2 is 0, x3 is 0, if I put x1 here, what it is coming out to be? 0. So what is your solution vector? x1, x2, x3. What is your solution vector? Solution vector is 0, 0, 0. So now what this is known as? Sir, this is known as only one solution is possible, no? So this is known as, sir, unique solution. or what you can call it, trivial solution, or there is another name. The name is zero solution. What is the name? Zero solution. Now someone would say that, sir, is it representing the number of solutions? No. What I mean to say is that zero solution does not mean no solution. Zero solution does not mean no solution. What is the meaning of zero solution? Zero solution means all the variables are zero. Zero solution means zero solution simply means all the variables are zero. All the variables are zero. So in the examination, if it is written, this set of equation is given. The set of equation has option A, consistent solution. Yes, consistent solution. That means if solution is existing, then consistent solution would be there. Consistent solution. Option B, trivial solution. Yeah, that is also correct. Option C, zero solution. Zero solution means, what is the meaning of zero solution? That means all variables should be zero. Yes. And option D, no solution. This will be wrong. Why it will be wrong? No solution means no, it is having some solution. No. So consistent solution correct, trivial solution correct, zero solution also correct, and no solution means there is no solution exists, which is not possible. Solution is existing. What is the solution? 0, 0, 0. And you can check in the equations as well. If I put 0, 0, 0 here, I will get the same answer. What I mean to say is that if I put 0 plus 0 plus 0, 0, 0, 0, 0, 0, 0, 0, so 0, 0 is the solution. Understandable? Let's make the matrix representation. This is the matrix representation we are having. This is our matrix A, and this is our matrix 0. 0 matrix is there. No? So here I don't need to make a 0 matrix separately. I only need to consider matrix A. If I consider matrix A, what I am doing, I am considering only matrix A. I am considering only matrix A and find out the rank of this matrix A. What is the rank of this matrix A? Can you find out the rank of matrix A? For sure, sir. I can find out the rank of this matrix A. What I will do is that I will apply the operations that R2 is being replaced with R2 minus 2R1 and R3 is being replaced with R3 minus R1. So I am finding the rank, sir. I will notice one thing, the rank will come out to be 3 only. So 1, 1, 1, 0, 1, minus 1, right? Twice of this you are subtracting, and then 0, 1, 1, right? 0, 1, 2. Next, what you are going to do? Next, you are going to do is that from R3, you are going to subtract R2. So what you will be getting? 1, 1, 1, 0, 1, minus 1, 0, 0, and 3. There you go. What is the rank here? Rank of A is coming out to be 3. So rank of A is coming out to be equals to 3. That is equals to the number of variables, and which is representing a unique solution. What it is representing? A unique solution. There you go. Okay. The similar scenario we will see in the next example as well. We will write down the conclusion, but as of now it is completely clear. You solve the equation. This is the answer you are getting. You calculate the rank of A. I am not calculating A augmented B here because this is a zero matrix, no? So I am only calculating rank of A. Rank of A is coming out to be 3. If I would have calculated A augmented B, then what would be the scenario? Here I would have written rank of, here I would have written A, and here I would have written 0, 0, 0. Rank of A is coming out to be 3. That means this is what we are getting. 1, 1, 1, 0, 1, minus 1, 0, 0, 3. What will be the rank of A augmented B? That will be 3. And have we studied this condition that rank of A equals to rank of A augmented B equals to number of variables? Then what is the solution? Unique solution. This is what we are writing down. That's it. Nothing else. It is the same only. Here it is not necessary to write down this 0, 0, 0. Whatever that we studied for the case of non-homogeneous equation, whatever the table that we studied here for non-homogeneous equation, the same we can study for homogeneous equation as well. But here it is not necessary. No, you already know it is 0, 0, 0 only. always. So no changes will happen here. If you multiply this row with 2, this row with 3, this row with 5, whatever you do, all these guys will always remain 0. So if rank of A is coming out to be 3, then for sure rank of A augmented B is also 3. Are you able to understand this point? If let's just say rank of A is coming out to be 2, let's just say this was the scenario. Rank of A is coming out to be 2. Then for sure rank of A augmented B will also be 2 only. Let's just say rank of A is coming out to be 1. Rank of A is coming out to be 1. Rank of A is coming out to be 1. Then for sure rank of A will be always equal to rank of A augmented B. That means what you can understand, that always rank of A will be equal to rank of A augmented B. Always. In case of a homogeneous equation. In case of homogeneous equation, what you have understood, that always rank of A would always be equal to rank of A augmented B. What does that mean? We will always have consistent solution, or I can say always the solution would exist. Solution would always exist. But if solutions are existing, then there are two conditions, either unique solution or there are infinite solution. So there can never be a condition that solutions are not even existing. Why is that so? Let's just assume I write down any equation. Any equation I'm writing down. Any random equation. Any random equation. x1 plus x2 plus x3 equals to 0. 2x1 plus 4x2 plus 3x3 equals to 0. This equation, this set of equation I have written down. I need to check whether it will have 0 solution, 1 solution, what it will have. I can 101% say that 0, 0, 0 will always be a solution. What I mean to say is that x1 plus x2 equals x1 equals to x2 equals to x3 equals to 0 will always be a solution. Because if you put 0, 0, 0, 0, 0, 0, it will be always equals to 0. So one solution will always exist. In case of a homogeneous equation, one solution will always exist, that is this solution. No one can stop it because all are equated to 0, no? So if you put 0, 0, 0 here, 0, 0, 0 here, 0, 0, 0 here, then always 101% I am sure that one solution will always exist. It might happen that more than one solution are there, but one solution will always exist. Is that understandable to you or not? So in case of homogeneous equation, one solution will always exist. And why is that so? Because this kind of matrix we will get here always 0, 0, 0 will be there. So whatever the rank of A you are getting, the same rank of A augmented B also you will get. Is that understandable to you or not? Because let's just say if this row is 0, 0, 0, then complete row will be 0. If this row is 0, 0, 0, then complete row will be 0. So whatever the rank of A you get, the same rank of A augmented B also you will get. And that means solution would always exist. Okay. As of now, we have seen the condition that only one solution is there, which is this one. Only one solution is there. Let's see the other example. Let's see this example. So what we can see here, you can see one thing, that equation 1 and 2 are same only. Why is that so? Why equation 1 and 2 are same? Take 2 common, so it will become x1 plus x2. 0 divided by 2 will be 0 only, so they are same. So effectively you are given only two equations, which are x1 plus x2 plus x3 equals to 0. Here if I take 2 common, then it will become x1 plus x2 plus x3 equals to 0 only. And the other equation is x1 minus x2 plus x3 equals to 0. If I add both of these equations, what I will get? You will get 2x1 plus 2x3 equals to 0. If I am adding both of them. If I add both of them, so 2x1 plus 2x3 equals to 0. And you are getting x1 plus x3 equals to 0. So this is one equation you are getting. Now you know that x1 plus x3 equals to 0. So using this equation in 4, x1 plus x3 equals to 0. So what I am saying, x1 plus x2 plus x3 equals to 0 they are saying. So x1 plus x3 equals to 0, then for sure x2 will come out to be 0 only. So x2 has to be 100% 0. x2 has to be 100% 0, but x1 plus x3 should be 0. So someone would say that, sir, if I keep x1 as 3, x2 is for sure 0, then x3 has to be minus 3. Because what is the answers we are getting? These are the answer we are getting. This is the answer we are getting and this is the answer we are getting. The x1 is 3, x2 is 0, x3 is minus 3. If someone says that, sir, if I keep x1 as minus 1, x2 is for sure 0, then sir, x3 has to be plus 1. Someone would say, sir, I will keep x1 as 9, x2 for sure will be 0 and x3 is minus 9. So if someone would say that, sir, I am keeping x1 as t, x2 is for sure 0, then x3 has to be minus t. So what will be your solution vector? The solution vector would look somewhat like this. x1, x2, x3. This will become 1. Oh, sorry. This was t, this was 0, and this was minus t. This is how the solution vector would look like. Number of independent solution, let me know. Number of free variables or number of independent solution. Number of free variables, you can say, or number of independent solution. What is the answer? What is the number of free variables you are having? Only one free variable you are having, no? Because this is fixed. This is free. That, sir, I can take any value. If t takes value 1, then minus t will take value minus 1. If t takes value 3, then minus t will take value minus 3. If t takes value 9, then minus t will take value minus 9. So number of free variable is 1. There you go. And how many solutions you are having? Infinite solutions you are having. How many solutions? Infinite solutions. Infinite solutions. Can we check in other way? Yes, sir. This is our matrix representation. This is our matrix A. So let me write down the matrix A, sir, and then I will calculate its rank. And you will notice one thing, that rank of A is coming out to be lesser than the number of variables. Rank of A will come out to be the lesser than the number of variables. What transformation you will apply? Simple transformation, sir, I can directly see is that R2 will be replaced with R2 minus R1. And then, sir, R3 will be replaced with R3 minus R1. So what I will be getting? 1, 1, 1. So R2 is replaced with R2 minus 2R1, right? 0, 0, 0, 0, minus 2, 0. Okay, then you can interchange as well. Next thing you are doing is interchange. So how will you interchange? 0 minus 2 goes upward and this goes downward. 0 minus 2, 0 and 0, 0, 0. I have interchanged as well. So what is the rank of A you are getting? This is a non-zero row, this is a non-zero row. So rank of A you are getting as 2, which is less than the number of variables. So rank of A you are getting as 2, which is less than the number of variables. What does that mean? That means there will be infinite solutions. Infinite solutions. And can anyone let me know what is the nullity of A? So nullity of A will be number of variables. How many variables are there? 3 variables are there. Minus the rank. What is the rank? 2. Nullity of A is 1. So what this 1 is representing? Number of free variables or number of independent solutions. So similar thing, whatever that we have studied, ditto same thing we are doing. Nothing new is there. The only thing is that this time inconsistent solution will not exist. So this time there will be two kind of solutions, either trivial solution or non-trivial solution. What is the meaning of non-trivial solution? Infinite solutions. So what is the meaning of non-trivial solution? Infinite solution. Infinite solution. And what is the meaning of trivial solution? Trivial solution means unique solution. And what is the condition? Condition here is rank of A should be equals to n, and here the condition is rank of A should be less than n. Right? So these are the condition. And what is n here? N representing the number of variables. Number of variables. Or you can say it is equals to the number of columns in A. Why it is number of columns in A? I have explained it a lot of times. The number of variables will be equals to the number of columns in A. Right? Understandable? Another thing is there. If there is a unique solution, then I already know the answer. For the case of homogeneous equation, which is Ax equals to 0, if the solutions are unique, if the solutions are unique, then I already know the answer. The answer would be 0, 0, 0. So if there is a unique solution, then I already know that my solution vector would be a null matrix, or you can call it zero solution. Is that clear to you or not? Okay. And what will nullity of A will represent? Nullity of A is nothing but a number of variables minus rank of A. And what this will represent? Number of independent solutions. Is that understandable to you? Is that understandable to you or not? There is no doubt at all. Everything is clear to you. This slide is clear, and this particular slide is also crystal clear. Absolutely, sir. Whatever that you have written, every single thing is clear to me. Here, sir, two conditions were there: no solution and solution. You can call it inconsistent solution, consistent solution. Inconsistent solution means rank of A will not be equal to rank of A augmented B. Consistent solution means rank of A will be equal to rank of A augmented B. But if it is coming out to be lesser than the number of variables, that means there will be non-trivial solution or infinity solution. And if it is coming out to be equal to the number of variables, that means there will be trivial solution. And sir, here nullity of A, what that is equals to? Nullity of A is equals to number of variables minus rank of A. That will represent what that will represent? Number of independent solutions. That's it. And here, for this particular condition, for the homogeneous equation, so I don't need to care about A augmented B, because I know that B is already a null matrix. So whatever the rank of A I will get, I will always get the rank of A augmented B same. So rank of A will always be equal to rank of A augmented B. That means solution will surely exist. It cannot happen that solutions are not even existing. Solution will surely exist. And if solutions are existing, then there could be two kinds of solution, either unique solution or infinite solution. Unique solution, rank of A would be equal to the number of variables. And if that is I am getting, then I know the unique solution. Unique solution has to be a zero vector only. That means all the variables will have zero value. X1, X2, X3, X4, X5 all will have zero value. And if there are infinite solution, that means rank of A will be less than the number of variables. Okay. And what will nullity represent? Nullity will represent the number of free solutions or number of free variables or number of independent solutions. And that would be equal to the number of variables minus rank of A. And number of variables would always be equal to the number of columns in matrix A. Everything is absolutely crystal clear. No mug up, nothing. Reasoning is also clear. Concept is also clear. Intuitions are also clear. And remembering part is also clear. Everything crystal clear. Say yes or no. Now what we need to do is that we need to solve the questions. So roughly around 20 questions we are going to solve. This question I have written. This question I have written. This question I have written. Everything is about question now. Okay. Concepts are done. Question and question we are going to solve. Okay. So roughly around 20 questions we are going to solve. Let me take a break because it's been roughly around 2 hours. No, 2 hours, 1 hour 47 minutes. So concept part is gone. Now we need to solve the problem. So I will take a break and then we will come back and start solving the questions. Like, can you think of this particular question that find the value of alpha and beta such that this particular set of equation is having infinite solutions? What is the condition of infinite solution? This is a non-homogeneous equation. What is the condition? Rank of A should be equal to rank of A augmented B should be less than the number of variables. So try applying that condition, make A augmented B and find out the value of alpha and beta. You will see something, you will be able to find out the value. Is that understandable to you? So try doing it. I hope you will enjoy it and you will be able to do it as well. Understandable? So try it on your own. Yes. So let me take a break and then I will come back and we will solve these problems. Yeah, welcome back. So did you try this question? What we need to do? First, what we need to see what kind of equation it is. Is it a homogeneous equation or non-homogeneous equation? So it is a non-homogeneous equation. Non-homogeneous equation. Okay. What you want infinite number of solutions. What does that mean? The rank of A should be equal to rank of A augmented B because we want some solutions, but we want infinite number of solutions. That means it should be less than the number of variables. How many variables we are having? X, Y, Z. 3 variables we are having. So rank of A should be equal to rank of A augmented B should be less than 3. This is our target. So can I make A augmented B? Because if I make A augmented B, then there I will be able to see matrix A as well, right? Because in A augmented B, you will have matrix A as well. So I am making A augmented B matrix. So 1, 1, 1, 5, 1, 3, 3, 9, 1, 2, alpha, beta. This is the scenario we are having. Okay. What we need to do? We need to apply the transformations. R2 is being replaced with R2 minus R1 and R3 is being replaced with R3 minus R1. Why is that so? Because we know that this will become 0, 0. So we will be able to get something good. Right? So what we are getting? All these things you should be doing on your own. You should not be looking at the solution. Because now since I have given more than enough concept, this much thing should not be very tough for you. And this will be 0, this will be 1, this will be alpha minus 1 and this will be beta minus 5. Say yes or no. Understandable? Right? Next, what I need to do? Next, this 1 is creating the problem, no? So I will subtract the half of it from here. What I am doing is that in R3, I am subtracting half of R2. This is what we are doing. One, 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 augmented 5, 0, 2, 2, augmented 4, 0. Half of 2 will be 1. So this will become 0. This will be alpha minus 2. And half of 4 will be 2. So this will become beta minus 7. Right? This is the matrix you are getting. I hope you are able to see it. Five, 4, beta minus 7. This is what we are getting. Right? Now you want infinite solution. That means rank of both of them should be equal and should be less than 3. Now you are pretty sure that rank will be at least 2. Why is that so? Because these two are non-zero rows. So rank will be at least 2. And you want it to be less than 3. That means what will be the rank here? Rank of A, you want that to be equals to rank of A augmented B. Now you know that rank will be at least 2. Because these two are non-zero rows. So if it is at least 2 and you want it to be less than 3, then what will be the number? Number will be 2 only. So you want the rank to be 2. Both of the ranks to be 2. That means this should be equated to 0 and this should be equated to 0. That means alpha minus 2 should be equated to 0 and beta minus 7 should be equated to 0. If I say alpha is not equals to, if I am saying that alpha is equals to 2, but beta is not equals to 7, let's just say beta is 6. If I say this thing, then what will happen? If I put beta equals to 6 here, what it will become? 6 minus 7, that will be minus 1. So here I will get 0, 0, 0, but here I will get minus 1. So what will happen? Rank of A will be 2, but rank of A augmented B will become 3. That means it will be the condition of no solution. You want infinite solution. So if you want infinite solution, then this is the condition you need to satisfy. That both of them should be 0. If both are 0, then what will happen is that last complete row will become 0. So rank of A will be equals to rank of A augmented B will be equals to 2. Is that understandable to you or not? Very simple thing. So what will be the answer you will be getting? Alpha equals to 2 and beta equals to 7. So alpha equals to 2 and beta equals to 7. This is the answer we are getting. Alpha equals to 2 and beta equals to 7. Now you can put it here and you can verify it as well. How you can verify it? Like if you put 2 here and 7 here, if I put 2 here and 7 here, then you see one thing that add these two equations, or what you can see is that seven, 4, wait a second, something 1115, 1339, 2x. Yeah. So what we can see is that if we add both of these equations and then divide by 2, x plus x will become 2x, 2x divided by 2 will be x. 3y plus y will become 4y, 4y divided by 2 will become 2y. 3z plus z will become 6z, 6z divided by 2 will become, sorry, 3z plus z will become 4z, 4z divided by 2 will become 2z. 9 plus 5, 14, 14 divided by 2 will become 7. That means addition of these two equations, let us say equation 1 plus equation 2 divided by 2 will become equation 3. That means equation 3 is linearly depending on equation 1 and 2. What does that mean? That means there are effectively only two equations, because this equation is linearly depending on upper two equations. So there are effectively only two equations. So two equation and three variables. Two equation, three variables. What does that mean? There will be infinite solution. And one free variable would be there. Right? So this is how you can check as well. In a very good manner, we can check. So alpha value should be 2 and beta value should be 7. Let's go to the next question. X plus y plus z equals to 3. This is a MSQ question. So this set of equation will not have a unique solution for what value of k? For what value of k, it will not have a unique solution. So what all conditions we have? Not unique solution. We don't want unique solution. So which all condition we can have? One condition we can have is that rank of A is not equal to rank of A augmented B. So this will give no solution. Or the other condition you can have is rank of A is equals to rank of A augmented B, but it should be less than the number of variables, which is 3. So two conditions we can have. At the end of the day, I will have to make A augmented B matrix for sure. So let's make A augmented B matrix. And then I will have to calculate its rank. And then we will see which condition we are able to make. One of the condition we need to satisfy. So let's see which condition we will be able to make. So 1 1 1 3, 1 2 3, 4, and 1 4 K 6. What transformation you are going to apply? Without writing the operation, I am going to apply the transformation now. So what transformation we are doing? In R2, what we will do is that we will subtract R1. R1 as it is 1 1 1 3. 1 1 1 3. This is as it is. Now 0 1 2 1. Right? 0 3 K minus 1 and 2. Right? 1 minus 1 0 3 2 and 1. Is it in the row echelon form? No, still it is not in the row echelon form. Next, what I need to do? Thrice of this you subtract from here. Is that clear to you? Thrice of R2 I will subtract from R3. So what I will get? Here you understood? No, from R2 we have subtracted R1. So 1 1 1 1 3. So 0 1 2 1. And from R3 we have subtracted R1. So 1 1 0 2 K minus 1. Sorry, 0 4 minus 1 is 3. K minus 1 and 6 minus 3 is 6. Sorry guys. Sorry, 6 minus 3 is 3 here. Here I will get 3. 4 minus 1 is 3. K minus 1 is K minus 1 only. 6 minus 3 is 3. Next, what we are doing is that thrice of this we are subtracting. So 1 1 1 3 0 1 2 1 and then thrice of this. So 3 times 0. 3 times K minus 7 it will become, and 3 times it will become 0. Is that understandable to you? What we have done in R3 we have subtracted 3 R2. Now let me know one thing. Can you ever get this condition? If I put K equals to 7, then what will happen? If K equals to 7, then what will happen? Rank of A will become equals to rank of A augmented B, and that will become equals to 2. That will show infinite solution. Infinite solution. And if K is not equals to 7, then what will happen? If K is not equals to 7, then what will happen? Then what will be the rank of A? If K is not equals to 7, let's just say K is 6. So here what will come? In place of this, what will come? Minus 1 will come. So what will be the rank of A? 3. What will be the rank of A augmented B? That will also be 3. Because all the rows will be non-zero, no? All the rows will be non-zero. So in place of K, if I put 6 here, then it will become minus 1. So if you see this matrix, what will be the scenario? Rank is 3. And if you see this matrix, then also rank is 3. So if your K is not equals to 7, then rank of A would be equals to rank of A augmented B only, and that will be equals to 3. And that will show unique solution. That will show unique solution. So what should be the value of K? That should be 7 only. I deliberately wrote down MSQ here because what people will think that, yes sir, K should not be 7. So they will click on 6, 5 and minus 2. So you need to think there, okay? They can frame the MSQ, but only one could also be correct. So there you need to think, okay, not having unique solution. That means, sir, no solution condition can also be there, and infinite solution condition can also be there. So I thought of both of the conditions. First, I converted into row echelon form. Is it a row echelon form? Yes. Row echelon form I have got. I have got the row echelon form. Sir, since I have converted into row echelon form, now I will be thinking. What I will be thinking? That, sir, if I put K equals to 7, then rank of A would be equals to rank of 2. Sorry, rank of A would be equals to rank of A augmented B. That will be equals to 2, which will be less than number of variables. That means there will be infinite solution. And if I don't put K equals to 7, then what I will get? I will get a unique solution. Why is that so? Because rank of A would be equals to rank of A augmented B, that would be equals to 3. Is that understandable to you? So there is no chance that you can get this condition. You can never get this condition here. Why is that so? Because you know that this element is becoming 0. If this element was, let's just say 2, let us say in place of 0, if it was 2, then if you put k equals to 7, what will be the condition then? Then you would say that there will be no solution. Because if it was 2 and if you put k equals to 7, what will happen then? 0, 0, 0 and 2. So rank of A would be 2 and rank of A augmented B will be 3. Both of the ranks are not matching, then it will be the condition of no solution, but it is 0 this time. So if you put k equals to 7, both of the ranks are becoming same. Understandable? Very straightforward. Solve this question now. X1, X2, X3, it will have unique solution. What is the condition of unique solution? Unique solution will say that rank of A should be equals to rank of A augmented B, and that should be equals to number of variables, which are 3. Right? So A augmented B we are writing down. You need to find out the value of A. 1, 1, 2, 1, 1, 2, 3, 2, 1, 4, A, 4. Again, apply the transformations on your own. Till this point, like a lot of times we have calculated the rank. Okay, from next lecture onwards, I will not calculate the rank. You will calculate the rank on your own. Here I am writing down these steps. No, in the next lecture, I will not even write down these steps. I will simply calculate it on my own, and then simply I will write down that this is the rank that we are getting. Three A minus 2, 3. Okay, 1, 1, 2, 1, then 0, 1, 1, 1, then 0, 3, A minus 2, 3. Do the thrice of it and then subtract. 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 Let me know the answer. If A equals to 5, then what will happen? If A is equals to 5, then what will happen? If A equals to 5, then rank of A would be equals to rank of A augmented B, and that will be equals to 2, which is less than the number of variables. This will show infinite solution. If A equals to not equals to 5, then rank of A would be equals to rank of A augmented B, and that would be equals to 3. Because let us say A is 4, or let us say A is 1. If A is 1, then what you will get? 1 minus 5, that will be minus 4. So rank of A would be equals to rank of A augmented B, that would be equals to 3. And that will show unique solution. Understandable? So what could be the answer? These are the answers. That A cannot be equals to 5. So will you be able to think in this manner in the examination hall? I hope you will be able to think. Let's write down another question. I'm just going to do a minor change. What change I'm going to make? First, I'm going to copy this slide. Oh yeah, I copy. Yes, the slide is copied, and one minor change I'm going to do here. I'm going to put 5 here. I'm going to put 5 here. Okay. So next question it is like previously this was the question. Now I'm changing the question now. In place of 4, I have put 5. Okay. And forget about all these things. Here it will be 5. So what question I'm going to frame? We'll have no solution for this is the question that is being framed. What is the meaning of no solution? No solution means rank of A should not be equal to rank of A augmented B. This is what we want. Okay. So what we have done, we have framed A augmented B matrix. This is our A augmented B matrix. This is the question that we have framed. This is the question. Okay. You need to find out the value of A for which there is no solution. So what we have done, 1 1 1 1 2 1 1 2 3 2 1 4 A 5. Then what I have done in R2 I have subtracted R1. So 0 1 1 1. Then 0 3 A minus 2 and 5 minus 1 will be 4. Okay. And then what I am doing, thrice of it I am subtracting. So thrice of it, this will be gone, thrice of it will be 5 and this will become 1. I want no solution. If A equals to 5, then what will happen? What will be the rank of A? If A is equals to 5, then rank of A will become 2. And what will be the rank of A augmented B? Even if this is 0, then for A augmented B, there are 3 non-zero rows. 0, 0, 0, 1. This is also non-zero row, this is also non-zero row, this is also non-zero row. Right? So there will be 3 non-zero rows. There will be 3 non-zero rows. So from here, what do you get? Both are not equal. So value of A is 5. And what if A is not equals to 5? If A is not equals to 5, then what will happen? What will be the rank of A? If A is not equals to 5, let's just say A is 2. So 0, 0, minus 3. So what will be the rank of A? All 3 rows will be non-zero rows. So rank of A will be 3. And what will be rank of A augmented B? Rank of A augmented B will be this much. If A is not equals to 5 or let's just say A is 3, then 0, 0, minus 2, 1. So rank of A augmented B will be 3. This will show unique solution. So what will be the answer? This will be the answer. Is that understandable to you? This was the previous question. Right? Here you wanted both of them to be equal. So that's why you put A equals to 5. So in that manner, you will be able to make the row echelon form, and eventually you need to see the condition, what they are asking. No solution. That means both of the ranks should not be equal. So if I put A equals to 5 here, then the rank here will become 0. Sorry, the rank here will become 2, and the rank for this one will become 3. So 2 is not equals to 3. So yes, that will be my answer. In this particular question, what I will see? I want unique solution. That means rank should be equal. Rank should be equal, and they should be equal to number of variables. What does that mean? I don't want to put A equals to 5 here. Because if I put A equals to 5 here, what will happen? The last row will completely become 0. So rank of A would be equals to rank of A augmented B, but that would be less than the number of variables. Then we will have infinite solution. So what will be my condition? I don't put A equals to 5. If I don't put A equals to 5, then what will happen? Rank of A will be 3. Rank of A augmented B will also be 3. And both will be equal, and they will be equal to the number of variables. So we will have unique solution. What was this question? In this question, you wanted to find the value of K for not having the unique solution. Not having unique solution means there could be the condition of no solution and infinite solution. So when we calculated the row echelon form, we got to know that we can never get the condition of no solution. Why is that so? Because if I put K equals to 7, then I am getting the condition of infinite solution. And if I put K not equals to 7, then I am getting the condition of unique solution. Understandable? This is how we are going to check in the examination hall. Understandable? So these kind of questions are very famous. Very famous kind of questions these are. What about this question? 2, 3, 6, Q. The value of Q for non-trivial solution. What is the meaning of non-trivial? Infinite. Right? What do you want? You want infinite solution. If I want infinite solution, what will be the condition? This is a homogeneous equation. Homogeneous equation. What do I want? Rank of A should be less than the number of variables. That means how many variables are there? 2. So rank of A should be less than 2. What is my A? A is 2, 3, 6, Q. This is my A. Rank of A should be less than 2. And this is my A. If rank of A is less than 2 and A is a square matrix, rank of A is less than 2, A is a square matrix, A is a square matrix. And I am saying that rank of A is a less than 2. A is a square matrix of a 2 cross 2 order. And the other thing I want is that rank of A should be less than 2. So can I say this particular condition what it will reflect? It will reflect that determinant of A should be 0. Or what you can do is that you can convert it into row echelon form. How will I convert it into row echelon form? So this will be 2, 3. Do the thrice of this will become 0. Do the thrice of this, it will become q minus 9. What do I want? Rank of A should be less than 2. That means this value I want to be 0. Because the rank of A less than 2 means the rank of A has to be 1. So I want q minus 9 to be 0. So what is the value of q you will be getting? Value of q you will be getting as 9. But another thing I want you to notice is that what do I want you to notice? That you want a non-trivial solution, infinite solution you want. If you want infinite solution, that means rank should be less than 2. Now A is a matrix of order 2 cross 2. And if rank is less than 2, what does that mean? That means its determinant should be 0. Do you remember that question in the last lecture? If A is reversible or if A is non-reversible. So if A is non-reversible, then its rank will be less than n. If A is non-reversible, then rank of A is less than n. It could be anything n minus 1, n minus 2, n minus 7. It could be 2, 1, whatever it is. But if A is reversible, okay, if A is non-reversible, then this is the condition. And if A is reversible, what does that mean? This will be non-zero. That means rank of A would be n. So if rank of A is less than n, that means A is non-reversible. If A is non-reversible, what does that mean? They should be 0. Right? So determinant of A put equals to 0. What is determinant of A? Determinant of A will simply be q multiplied with 2, 2q, 6 multiplied with 3, 18. That should be equals to 0. So q is equals to 9. Understandable? So this is how I could solve it. I could have solved it. x1, 2x2, 3x3, 4x4 equals to 7, 2x1, 4x2, 3x2 equals to 14. Nature of solution. What should be the nature of solution? We are having 4 variables and we are given 2 equation. 4 variables, 2 equation. For sure there will be 3 variables, no? 4 variables, 2 equation. For sure there will be 3 variables. How many free variables would be there? Sir, as of now I don't know. The other question is find the number of free variables. Find the number of free variables. What we saw here, that's our 4 variables and 2 equations. It might happen that it is effective 1 equation only. Are you able to understand this point? Let's just say x plus y equals to 2 I have given and 2x plus 2y equals to 4 I have given. So they are 2 equation, but effectively they are 1 equation only, no? Because you know that if I take 2 common, so x plus y equals to 2 only we are getting. So, but what I have written, 4 variable 2 equation. So either the equation could be 2 or it could be 1. Maximum equation could be 2 only, no? Maximum equation are 2. So with 4 variable you are getting 2 equation. That means for sure there will be 2 free variables. For sure. It might happen that there are three free variables. It might happen there are 3 free variables. But for sure at least 2 free variables would be there. So at least I can tell the nature that for sure it will be non-trivial. Can I say that? No. I cannot for sure say that it will be non-trivial. It could be inconsistent as well. Why is that so? Because who knows, both are representing the same equation. And let's just say in place of 14, 10 was written. So if I take 2 common, what I will get? x1 plus 2x2 plus 3x3 plus 4x4 divided by 2. So it will become 5. So here they are saying that x1 plus 2x2 plus 3x3 plus 4x4 is 7. And here they are saying that x1 plus 2x2 plus 3x3 plus 4x4 should be equal to 5. Then it can have inconsistent solution as well. So you need to know everything about both of the equation. Are you able to understand this point? So directly never ever click that it will be non-trivial or inconsistent. Always check. What you need to check? A augmented B you need to check. What will be your A augmented B? 1, 2, 3, 4 augmented 7. 2, 4, 6, 8 augmented 14. Can you apply the transformations? Yes, sir. When I apply the transformation, what I will get? 1, 2, 3, 4 augmented 7. And what I am doing is that in R2, I am replacing R2 minus 2R1. What I will get, sir? 0, 0, 0, 0 and 0. Right? Twice of R1 I have subtracted. So what I have seen here is that rank of A is coming out to be rank of A augmented B. That is coming out to be 1, which is less than the number of variables. 4, what does that mean? Infinite solutions are there or non-trivial solutions are there. And what will be the number of free variables? number of free variables. That will be number of actual variables were 4 and rank was 1. So number of free variables would be 3. This will be the number of free variables and solutions will be non-trivial. Okay, so there was effectively one equation given for 4 variables. For 4 variables, there were effective one equation. That means 3 variables will be free. There was effectively only one equation, no? x1 plus 2x2 plus 3x3 plus 4x4. Effectively only one equation was there. So one equation was given for 4 variables. That means 3 variables will be free and other variable will be dependent. So 3 free variables were there. So solutions were non-trivial. And in place of 14, if I had written anything else, let's just say 12 I had written, then the solution would be inconsistent. Why is that so? Because then rank of A would not match with the rank of A augmented B. Why is that so? Because the double of 7 will be 14. 12 minus 14 will become minus 2. And it is pretty obvious that if I take 2 common from here, I would get to know that both of the equations are different. x1 plus 2x2 plus 3x3 plus 4x4 is representing 7. x1 plus 2x2 plus 3x3 plus 4x4 will represent 6, which is not possible. Then I would say inconsistent solution. But as of now, both equations are same. So effectively one equation is given for 4 variables. That means 3 variables are free. Understandable? Let's move on to the next question. The system is consistent. What is the meaning of consistent system? The system is consistent. What is the meaning? That it can have unique solution or it can have infinite solution. And in both of the conditions, what do we know is that rank of A should be equal to rank of A augmented B. For consistent solution, this is the condition. Rank of A should be equal to rank of A augmented B. So this is the condition we need to satisfy. Rank of A should be equal to rank of A augmented B. So again, same scenario. Keep on doing the same scenario. Always you will get the answer. There is no chance that you will never get the answer. 101% you will get the answer. Just follow the process. So now you are able to understand that what is the importance of rank. Everywhere it is rank only. In the next lecture as well, all focus will be towards rank. Right? Your focus is also towards rank only. We all are doing it for the rank. Rank of a matrix or rank in gate examination. So all the focus will be towards rank, even in the next lectures as well. So first one as it is 1, 2, or can I see something? If I do double of add up or something, double of this or that, will I get something or not? No. Best possible method is this only. Subtract the double of it. This will become 0. This will become minus 1. This will become 9. This will become 9 minus 2a. And then subtract the 5 times of it. 5. This will become minus 1. 15. This will become 9. This will become c minus 5a. Right? Understandable? Next, what I need to do? Next, I need to do is that from R3, I need to subtract R2. From R3, I need to subtract R2. 1, 2, minus 3, A. 0, minus 1, 9, B minus 2A. From R3, I am subtracting R2. What I am getting? This is 0, minus 1, 1, 0. This is also 0. And C minus 5A. What we are getting? Here what we are getting? C minus 5A minus B plus 2A. So you are getting is C minus B minus 3A. Right? This is what you are getting. C minus B minus 3A. This is what you are getting. What is rank of A? Already we know that rank of A is 2. What does that mean? I want rank of A augmented B to be 2 as well. This is 2, no? Rank of A is 2. Rank of A is 2. You want rank of A augmented B to be 2 only. So if you want rank of A augmented B to be 2, what you want? You want the rank of A augmented B as 2. So this value should be 0. Because here whatever that is written, if that is 0, then what will happen? 0, 0, 0, it will become a 0 row. So non-zero row would be only 2. What does that mean? You would want C minus B minus 3A equals to 0. And that's the answer. What is written? 3A plus B minus C should be equals to 0. There you go. 3a plus b minus c should be equals to 0. Understandable? This is the answer. Okay, very straightforward equation. Just calculation we need to do and our job would be done. Okay, just checking the calculation. Then simply subtracting c minus 5a, c minus b minus 3a, 3a plus b minus c equals to 0. Yes. Let's go to the next question. Find the value of k for which the system has non-trivial solution. Non-trivial solution. Find the value of k for that. What is the meaning of non-trivial solution? Infinite solution. Infinite solution. What kind of equation it is? Non-homogeneous. Sorry. Homogeneous. Sorry guys. This is homogeneous. What does that mean? Rank of A should be less than the number of variables. How many variables are there? 3. So rank of A should be less than 3. This is what they are saying. So can I get A? Yes sir. What is your matrix A? Matrix A is nothing but 3k minus 8, 3, 3, 3, 3k minus 8, 3, then 3, then 3 and 3k minus 8. 3 cross 3 matrix. So your matrix A is a 3 cross 3 matrix and you are saying that rank of A should be less than 3. What does this represent? I am not telling now, you should know on your own. The determinant should be 0. There you go. So you need to make this determinant equals to 0. So put this determinant equals to 0 and you will get the answer. What you can notice is that I need to solve this determinant of A. Which determinant I need to solve? This determinant I need to solve. I will simply copy it. Okay. So in row 1, what you will get? What you can do is that what I am doing, can I apply this kind of transformation? Again, I am solving the matrix this time. Okay, I am solving the matrix. Sorry, I am solving the determinant. So all the linear transformation will not be valid. For determinant, there were different conditions, right? Do you remember in third lecture we saw? For calculating the determinant, the condition is that row 1 should be replaced with row 1 plus row 2 plus row 3. So row 1 plus row 2 plus row 3. So this will become 3k plus 1 and then 3 plus 3k minus 8 plus 3. What you will get? Basically, in row 1 I am getting, I am adding row 1 plus row 2 plus row 3. Is this acceptable? Yes sir, it is acceptable. Right? And why I am doing so? What will happen is that 3k minus 8 plus 3 I will get. So 3k plus 1 I will get. Then again 3k minus 8 plus 3 plus 3, 3k plus 1 I will get. Then 3 plus 3 plus 3k minus 8, 3k plus 1 I will get. And then I will be able to take it common. Right? So I will be able to solve it in a quicker manner. So 3k plus 1 I will be able to take common. So here 3k plus 1 I will be getting. Here also 3k plus 1 I will be getting. And here also 3k plus 1 I will be getting. And then 3 is there. 3k minus 8 is there. And 3 is there. And then 3 is there. 3 is there. 3k minus 8 is there. So now how I can write it down? That 3k plus 1 I can take common. Because when we solve the determinant, the common is taken from any of the row or from any of the column. So 3k plus 1 I have taken common. So isn't it looking easier now? Right? This is looking easier. Right? Do I have the page? Yes. I need to solve this determinant now. This determinant I need to solve. This is the determinant we are solving. So what I will do now? I can apply the, this is not the row echelon form. I am simply solving the determinant. So now what I can do, I can apply the operation in column as well. So what I am doing is that column 2 is being replaced with column 2 minus column 1. And who is getting changed? Column 2 is getting changed. So here I cannot use column 2, but what I can do, I can use column 1. Right? Did you understand what I am doing? Column 2 is being replaced with column 2 minus column 1. and column 3 is being replaced with column 3 minus column 1. Here it is getting changed, so I am not using it here. So all the operations are also valid. So 3k plus 1, and then just reducing the calculations, nothing else. All these things you will be able to do very well, very easily in the examination. So column 1 I am keeping as it is, right? So in column 2 I am subtracting column 1. So what I will get, 1 minus 1 will be 0. 3k minus 8, this will become 3k minus 11. Say yes or no. This will become 3k minus 11, and 3 minus 3, it will become 0. Right? This operation you don't need to do actually. Column 3 minus column 1. Or still if you are doing 1 minus 1 will become 0. 3 minus 3 will also become 0. And this will become 3k minus 11. Right? So what will be the determinant here? So total value is coming out to be 3k plus 1 multiplied with this determinant will be 3k minus 11. This is the determinant that is coming out to be, and you need to equate it to 0. You need to equate it to 0. So this should be equated to 0. So value of k could be either minus 1 by 3 or 11 by 3. So both of the answers are possible. Either minus 1 by 3 or 11 by 3. So both answers are possible. Understandable? Okay, both answers are possible. Very easy thing. You try this question on your own. Again, non-trivial solution, that means infinite solution you need. You will be able to solve it, okay? You try it on your own. I will take a break and then I will come back because someone is knocking at the door. Yeah, welcome back. Just one simple error I did here. That was this will become 3k minus 2. No? 3 plus 3 is 6. I made 3 plus 3 as 9. Okay, so this will become 3k minus 2. So these kind of minor mistake I do. Even in the main examination as well, I have done these kind of mistakes. When I was writing my gate examination, I actually attempted 64 questions out of 65. Okay, but a lot of minor mistake I did. These kind of mistakes I did. It is 3 plus 3 is 6, but you write down 9. What you can do? You are losing the marks there, right? Nothing else. And who knows, they have framed this option as well, minus 1 by 3. So everything would be gone, right? All the hard work, everything would be gone here. 3k minus 2, right? So this kind of blunder, please avoid. So 3k minus 2, 3k minus 2, 3k minus 2. So 3k minus 2 comes outward, and then k will be 2 by 3. And this is how you are solving it. Next question. Again, you want a non-trivial solution. That means infinite solutions you want. Again, make the matrix and you will be able to see. Infinite solution, homogeneous equation, rank of A, you would want to be less than the number of variables. X, Y, Z is the number of variables. So you would want it to be less than 3. And you can see that A will be a 3 cross 3 matrix. If you make the matrix A, it will be a 3 cross 3 matrix. Why is that so, sir? Because clearly I can see my matrix will become PQR, QRP, and RPQ. So this is the matrix I will be getting. And for sure I need, this is the scenario that I need. Rank of A should be less than 3. And this is the matrix A I am getting. What does that mean? That means the determinant of A should be 0. So I want the determinant of A to be 0. This is my scenario. PQR, QRP, and RPQ. I want it to be 0. This is what I want. Understandable? So simply calculate the determinant. P multiply with RQ minus P square minus Q multiply with Q into Q will be Q square minus PR, then plus R QP minus R square. That should be equated to 0. So what you are getting? PRQ, RPQ minus PQ minus Q cube plus this will become RPQ plus RQP or RPQ minus R cube. That is equated to 0. Right? So what I am doing is that I will write it down in this manner. That this has become P cube plus Q cube plus R cube. This all basically I am multiplying by negative sign on both of the side. So P cube plus Q cube plus R cube minus 3RPQ. minus 3rp cube, that is equal to 0. P cube plus r cube plus p cube plus q cube plus r cube minus 3rp cube equals to 0. So do you remember this formula? A cube plus b cube plus c cube minus 3abc equals to a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Right? Understandable? Say yes or no. Then there is another way as well, that this could be written as, I guess, you take 1 by 2 outside, a minus b whole square plus b minus c whole square plus c minus a whole square. Let's check. A square plus b square minus 2ab. So yes, this is how it would be written. So 1 by 2. If you just remember this one, then you will be able to write down this one as well. So eventually you are getting 1 by 2 into a plus b plus c plus a plus b plus c multiply with a minus b whole square plus b minus c whole square plus c minus a whole square. This is the condition. So from here, pq plus qq plus rq minus 3pqr should be equals to 0. So p cube plus q cube plus r cube minus 3pqr, that would be equals to 1 by 2 p plus q plus r multiply with p minus q whole square, q minus r whole square, r minus p whole square. And that should be equated to 0. And if you want this to be 0, then what is the answer you will get from here? What is the answer you will get from here? That means this should be 0. P plus q plus r should be 0. Or this should be 0. P minus q whole square plus q minus r whole square plus r minus p whole square should be 0. Now whole square will be a positive value, no? Q minus r whole square will also be a positive value, and this will also be a positive value. So positive value plus positive value plus positive value. Positive value plus positive value plus positive value should be equals to 0 when it is possible. Then the positive value is 0 only. That means this value is 0. This value is 0. This value is 0. Plus 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 should be equals to 0. What does that mean? This should be 0. This should be 0. This should be 0. That means p minus q should be 0. Q minus r should be 0. And r minus p should be 0. So from here what you are getting? P should be equals to q. Q should be equals to r should be equals to p. What does that mean? P should be equals to q should be equals to r. So what you are getting? Either this condition should be satisfied or this condition should be satisfied. So what is the answer? P plus q plus r equals to 0, or P should be equals to q should be equals to r. Understandable? So what we have done is that we know that we need to take the determinant to 0. So here the concept is ending. Here concept ends. After that it is complete mathematics. How you solve the determinant? This is how I solve the determinant. Then I go to know that this is the condition I am getting, that p cube plus q cube plus r cube minus 3rp cube. If this is the condition, then what I can conclude from here? That p plus q plus r is equals to 0, or p should be equals to q should be equals to r. Why is that so? This is the mathematics I have written. Remember this formula. Always remember this formula. This is used a lot of times. Please remember this formula. Okay? Remember this one. A cube plus b cube plus c cube minus 3abc equals to a plus b plus c multiply with a square plus b square plus c square minus ab minus bc minus ca. Then you will be able to write down this formula very easily. Right? A square plus b square minus 2ab, then b plus c square minus 2ab, then divided by 2 is there. So a square plus b square, this formula you will be getting. And then this is how you can write down. You need to equate it to 0. You need to equate it to 0. So if you need to equate it to 0, then either this should be 0 or this should be 0. If this is 0, then what will happen? P should be equals to Q, Q should be equals to R should be equals to P. So P should be equals to Q should be equals to R. That's it. Okay. So this is the answer we are getting. Let's go to the next one. 4 equations are given. This is a good question. Okay. Try solving it in a quicker manner. In the examination, in a very quick manner, we need to solve. Which of the following statements are true? Do it in a very quick manner. So what you will do? Sir, following set of equation A augmented B I will make. A augmented B I will make, sir. And then I will start solving it. These kind of questions we have solved, sir, in a great manner. 1 1 1 6 2, 1, 1, 7, 1, 2, 1, 8, 1, 1, 2, 9. These are the equations I have written. Okay, so you solve it and find the rank. Rank will come out to be 3. You can do it on your own. Rank will come out to be 3. Is that clear to you? Okay, let me check whether it will be 3 only or not. Yes, rank will come out to be 3. You can do it on your own. Find the rank. Till this point, we have done enough practice. You can surely do it on your own. And we can check as well if there is some shortcut. So I can tell the shortcut as well. There is no shortcut. You need to find out the rank. Rank will come out to be 3. So basically, the scenario would be somewhat like this. The scenario will look somewhat like this. That this will be 1, 1, 1, 6 only. Then here there will be some 0 element. This will be non-zero. This will be non-zero. And this will be non-zero. Then here these two will be 0 element. This will be non-zero. And this will be non-zero. And the last will be complete 0. This will be the scenario you will be getting. Here some non-zero element you will get. I don't know which non-zero element you will get. So this is the scenario you will get. So rank of A would come out to be equals to rank of A augmented B, and that will be equals to 3. Okay, I saw all 0 row. What does that mean? Infinite solution. So where I will click, it will have infinite solution. Something like that I will click. It has one independent solution, two independent solutions. So I will start thinking like that. It might have infinite solution. One of the option would be it has infinite solution. So you will click on this infinite solution. Absolutely wrong. It has unique solution. Why is that so? Rank of A is coming out to be rank of A augmented B. That is equals to 3. And what is 3? Number of variables. How many number of variables are there? How many number of variables are there? Number of variables are 3 only, no? So it is equals to number of variable. Number of variables. What does that mean? It is having unique solution. What a lot of people will do is that they will see all 0 row. Okay, sir, there is one all 0 row. That means there will be one independent solution. I have these kind of conclusion. I have seen these kind of conclusion in some class notes as well. That if you in A augmented B, if you see one all 0 row, that means it will have one independent solution. Absolutely baseless. One independent solution means they are saying that it will have one free variable. No, it will not have one free variable. Why is that so? They have given 3 variables and 4 equations they have given. 3 variable, 4 equations they have given. We have find out the rank and we got to know that rank is coming out to be 3. That means one equation was needless. So effectively there were how many equations? 3 effective equations were there. 3 effective equations were there. So effectively there were 3 equations. So 3 variable and 3 effective equation. Unique solution you will get. Is that understandable to you? 3 variables are there and 3 effective equations are there. Let's just say I write down x plus y equals to 2, x plus 2y equals to 3. What will be the rank of A augmented B? It will come out to be 2 only. That means there are 2 variables and effective 2 equations. So what will be the solution? Unique solution. And what if I write down these 3 equations? What if I write down these 3 equations? Forget about this. What if I write down these 3 equations? X plus 2y equals to 3. Next equation I am writing down. X minus 2y equals to 6. And next equation I have written down. 2x plus 4y equals to 6. So will it have infinite solution? No. Why is that so? Because you notice that equation 1 and equation 3 are same. Just to take 2 as common, x plus 2y equals to 3. Right? So effectively I was having only 2 equations. Effectively I was only having 2 equations. So 2 equation and 2 variable. That's it. These two are independent of each other. No, these two equations are independent of each other. So 2 equation and 2 variable. 2 equation and effective 2 variables. Sorry, effective 2 equation and 2 variables are there. What does that mean? Unique solution. So here I will be having unique solution. So x and y will give me unique solution. Is that understandable to you? So here as well 4 equations you see. It doesn't mean all 4 are independent of each other. Only 3 are independent of each other. And this thing I will prove in the next lecture that if you are taking a 3-dimension vector If you take an n dimension vector, then you can never create n plus 1 span. Okay, basically, if I have written three independent equation, if these are three independent equation, then for sure this equation will be depending on other three. What I mean to say is that if these three are independent, x plus y plus z equals to 6, 2x plus y plus z equals to 7, x plus 2y equals to z equals to 8. If these three are independent, then for sure this equation will depend on these three. That means fourth equation can be written as alpha time equation 1 plus beta time equation 2 plus gamma time equation 3. Equation 4 could be written as alpha time equation 1 plus beta time equation 2 plus gamma time equation 3. All these things we will see in the next lecture where we talk about vector span. Okay. So did you understand here that we were having three effective equation and three variables? Three variables were there and three effective equation were there. So eventually, what was the answer? Unique solutions were there. And if you solve by the simple method only, then also you will see that rank of A augmented B and rank of A was coming out to be equals to 3. And that is equals to the number of variables. That means it will have unique solution only. Okay. So this is also effective equation. This is also effective equation. This is also effective equation. This is all 0. So 0 equals to 0 is not an equation. So three variables and three effective equation. So number of variables are 3. So all 0 row doesn't mean that you will have one independent solution or you will have one free variable. No, this does not mean that you will have one free variable. That is no sense at all. It will have one free variable. This is absolutely baseless. Okay. This statement is absolutely baseless. If you are having a 0 row, that doesn't mean that shows the free variable or independent solution. No, you need to check how many variables are there. So number of variables were 3. What is the rank? Rank is also 3. What does that mean? There will be unique solution only. There is no independent solution. Understandable? I hope it is clear to you. Let's see the next question. A set of linear equation is represented by the matrix Ax equals to B. The necessary condition for the existence of a solution of the necessary condition for the existence of the solution of the system is. Think of it. Tell the answer. A lot of people will click on this none of the above. What they are saying? Necessary condition for the existence of the solution. Existence of the solution. What does that mean? Consistent. What do you need? Consistent solution. So what is your condition? Your condition is that, sir, rank of A should be equals to rank of A augmented B. That's it. This is the only condition. Let's make A augmented B. Let's make A augmented B matrix. So A, B, C, D, or A, B, C, D, E, F, G, H, I, J, K, L. Okay, this is my A augmented B. If I say rank of A is 3, then you know that for sure rank of A augmented B will also be 3 only, no? Rank of A is 3. That means all 3 are non-zero row. Then for sure rank of A augmented B will be 3 only. You know the one thing that rank of A can never be greater than rank of A augmented B. This can never happen. Or better, what you can write down, that rank of A would be always less than or equals to rank of A augmented B. This you already know, right? This you already know. Why is that so? This we have proved. If this is a all 0 row, then this might be non-zero. That means rank of A augmented B will be more. And if it is not a all 0 row, then for sure, even if this element is 0 or non-zero, rank of A augmented B will be equals to the rank of A only. So I am talking about rank of A augmented B. So rank of, in this condition, rank of A augmented B is coming out to be 3. That is coming out to be 3. Let's call this matrix as C. That means rank of C is coming out to be 3. What I can say? I can say that in matrix C, there are 3. What is the rank? Rank is 3. So there are 3 independent columns. And 1 dependent column, right? What do you represent by rank? What rank represent? Rank represent the number of independent rows and column. Rows and columns. Say yes or no. If this is the scenario we are getting, rank of A is equals to rank of A augmented B, that is equals to 3. What it is representing? That there are 3 independent columns and 1 dependent column. That means 1 column will be depending on 3. 1 column will be depending on 3. What is this part? This part is B. And what is this part? This part is A. So B must be linearly dependent on the columns of A. Say yes or no. I took the condition that rank of A is equals to rank of A augmented B, that is equals to 3. Sir, why you took this condition? Can we take other condition as well? Yes, you can take other condition as well. You can check other condition as well. As of now, we are checking this condition. We will check other conditions as well. Don't worry. So when I am checking this condition, what I got to know? That rank of A augmented B is coming out to be 3. That means there will be 3 independent columns and 1 dependent column. That means you can say that, sir, this column is depending on these 2 columns. Let's just call this as C1, this as C2, this is as column C3 and C4. So you can say that C2 is depending on C1, C3, C4. Or what you can say, C3 is depending on C1, C2, C4. Or what you can say, C1 is depending on C2, C3, C4. Or what you can say, C4 is depending on C3, C2, C1. And this last statement can be written as vector B is depending on the columns of A. Vector B must be linearly depending on the columns of A. So this could be one of the possible answer, right? But sir, you have checked only one condition. Let's check this condition. That sir, what if rank of A was 2? Rank of A was 2. What if rank of A was 2? If the rank of A was 2, then what would have been the scenario? And you want, what do you want? You want the existence of solution. That means rank of A would be equal to 2, would be equal to rank of A augmented B. That means here some A, B, C I will get, augmented D. Then here some 0 value I will get. Here let's just say E, F, or let's write down something else. Alpha, beta, gamma, and in last I will get 0, 0, 0. This is the scenario I will get, right? This is your A, this is your B. If I am saying that rank of A augmented B, or you can say rank of C is 2, what does that mean? There will be 2 independent columns, 2 independent columns and 2 dependent columns. So let's call this as C1, C2, C3 and C4. So what I will say? C4 is depending on C4 and C3 is depending on C1 and C2. Basically, this is a dependent column. No, C4 could be a dependent column. So C4 will surely depend on C1, C2, C3. It might happen that it is only depending on C1, C2. It might happen that C4 is only depending on C1 and C2. Because what is the scenario? 2 independent column and 2 dependent column. So it might happen that C4 is only depending on C1, C2. It might happen that it is only depending on C2, C3. But surely it is dependent, no? Are you able to understand this point? So vector B is depending on the columns of vector A, even if you take this condition. And this condition that you say A must be invertible, no, here A is not invertible. Here A is not invertible, not invertible. Still we are getting consistent solution. Consistent solution means the solution could be infinity as well, solution could be unique as well. If A is not invertible, then also you are getting, if A is not invertible, then also you are getting consistent solution. This is also consistent solution, but here the condition is infinite solution you are getting. Infinite solutions we are getting. But again, it is consistent solution only. This was also consistent only, but here unique solution we were getting. Here we were getting unique solutions. And one thing I am pretty easily I can write down. Let's just say these are the equation. 2x plus 3y plus 5z equals to 4. 3x plus 2y plus 4z equals to 5 and 2x plus 4y minus 6z equals to 7. Isn't it pretty obvious that what this will be? These guys will be the columns of A, right? 2, 3, 5, 3, 2, 4, 2, 4 minus 6. They will be the columns of A. Columns of A. If I am saying that vector A, B and C depends on, sorry, what I want to say is that vector D depends on A, B, C. So what do I write down? Alpha A vector, beta B vector and gamma C vector will be equivalent to D vector. Do you remember this statement? In the last lecture we saw it. So isn't it like this, that 4 is depending on 2, 3 and 5. Like 2 alpha plus 3 gamma, 2 alpha plus 3 beta plus 5 gamma equals to 4. So these are the 2, 3, 5 are the columns of A and this is your B. This is your B vector and these are the columns of A. So vector B is depending on the columns of A. This is the meaning of linear equation, no? 2x plus 3y plus 5z equals to 4. So vector of B is depending on the columns of A. Or you can understand by this particular scenario, that rank of A, if I take rank of A augmented B, I take, that will be 3. Any kind of system you take, it's not that 3 variable 3 equation you take. 3 variable 2 equation you take. 3 variable 2 equation, forget about this one. What you will see? What will be the maximum rank you will get? Rank you can get 2. Maximum rank you can get 2. What does that mean? Maximum rank that you can get is 2. What does that mean? That means that you are having 2 independent columns and 2 dependent columns. So this guy will be surely depending on this guy. Now someone would say that, sir, what if I would have taken 4 equations in 3 variables? 4 equation in 3 variable. Someone would say, sir, I would have taken 4 equation in 3 variable. 4 equation in 3 variable. So in the last question only I said one thing, that in 3 variables, if you are taking 4 equation, then for sure this equation will be depending on these 3 guys. 101% I am sure. If you are having 3 independent equation, then the 4th equation will surely depend on these 3 equations. Sir, why is that so? So when we study about the span in next lecture, it will be clear to you. Someone may raise a doubt. Someone would say that, sir, what if I write down 4 equation? Then sir, here I will get 2, 3, 5, 4, 3, 2, 4, 5, 2, 4, minus 6, 7. And sir, 4 minus 3, 7 and 9. So now the rank could be 4. Now someone would say that, sir, who knows rank of A coming out to be equals to rank of A augmented B, that is coming out to be 4. So if rank is coming out to be 4, that means, sir, all are independent of each other. This is what someone would say, but it is not possible at all. Rank of A and rank of A augmented B will surely come out to be lesser than 3. For sure. You can check it. For sure it will come out to be 3 or less than 3. It can never come 4. Because you are having 3 variables. In 3 variables, you can never make a 4-dimension space. If I am having I cap, J cap and K cap, can you make a 4-dimension space? If you are only having I cap and J cap, can you write down 3 I cap plus 4 J cap plus 5 K cap? You are not even having K cap, no? Right? Are you able to understand this point? And if I say I have 2 vector, 2 I cap plus 3 J cap, 3 J cap plus 4 K cap, are they independent of each other? Yes. Now I write down new vector which is 6 I cap plus 7 K cap. 101% I am sure that this vector will be depending on these 2 i's. For sure. 6 I cap plus 7 K cap will be depending on 2 I cap plus 3 J cap and 3 I cap plus 4 K. 3 I cap plus 4 J cap. For sure it will be depending. So if you are having 2-dimension space, then only 2 independent vector you can have. If you are having 3-dimension space, then only 3 independent vector you can have. If you are having 4-dimension space, then only 4 independent vector you can have. If you are having 3 variable, then maximum 3 independent equation you can have. The 4th one will surely depend on the rest 3. If you are having 3 variables, then maximum 3 linear equation you can have which are independent of each other. The 4th one will surely depend on the rest of 3. I will give you a complete visualization in the next lecture. Okay, complete visualization I will give you in the next lecture. But as of now, you can take any random example and try finding out the rank. Rank will surely come out to be less than 4. It can never come 4. So here someone might be thinking that, sir, rank is coming out to be 4. What does that mean? Rank of A equals to rank of A augmented B, that is equals to 4. That means, sir, all 4 vectors are, all 4 columns are independent of each other. So I can say that my vector B is independent of the columns of A. But it will never be possible. Why it will never be possible? Because with the 3 variables, I can make maximum 3 independent equation. So this row will surely come out to be 0, 0, 0 in the end. Is that clear to you? Okay. So you write down any 4 random equation and then put it in the chat GPT and then ask him that make a matrix A and tell me the rank. He will tell you the rank and you will see that rank will be always less than 4. Okay, this is how you can effectively use chat GPT. That write down any 4 random equation, put those equation in chat GPT and say that make coefficient matrix A and tell me make coefficient matrix A and make augmented matrix A augmented B and tell me the rank of matrix A and A augmented B. They will say that the rank is coming out to be lesser than 4 for sure. It can never come equals to 4 because with the 3 variables you can never get 4 independent equations. Is that clear? In a more than enough concept I have given, right? B is depending on, directly I can say that B is depending on A. B is a function of A. B is a function of A. Here we can directly see that 4 is written as 2x plus 3y plus 5z. Right? It could be said as 4 is written as 2 alpha plus 3 beta plus 5 gamma. 2 alpha plus 3 beta plus 5 gamma. So 4 is depending on 4 is depending on 2, 3, 5. 5 is depending on 3, 2, 4. And 7 is depending on 2, 4, minus 6. And how it is depending? This is how it is depending. So surely B must be linearly dependent on the columns of A. Is that clear? A very good question. It is a gate QIQ only. A is a 4 cross 4 matrix with the rank of 2. It is given that the system of equation is consistent, then which of the following statements are true? So rank of A consistent means it needs to have finite solution. Rank of A is 2. So rank of A augmented B is 2. The system will have unique solution? No. A is having a matrix of 4 cross 4, no? A is having a matrix of 4 cross 4. So how many number of columns it is having? Number of columns it is having is 4. If number of columns are 4, what does that mean? Number of variables are also 4. So number of variables are also 4. So it is less than the number of variables. That means it can never have unique solution. It will have infinite solution. And how many independent solution it will have? That will be equals to the nullity of A. So how many variables are there? 4. What is the rank of A? That is 2. So 2 independent solution it will have. 2 independent solution it will have. That's it. These kind of questions I am saying 90% of the aspirant will struggle. With very ease you are solving it because your concepts are clear. 4 cross 4 matrix is there, rank is 2. What does that mean? 2 equations are gone. Effectively only 2 equations we are having. 4 cross 4 means 4 variables will be there. So for 4 variables I am having effective 2 equation. That means 2 will be free variables. That means 2 independent solution I will have. 2 independent solution I will have. 2 free variables are there. That means surely I will have infinite solution. If consistent solution is there, that means rank of A should be equal to rank of A augmented B. That should be equal to 2. There you go. Nothing mug up, no mug up. Always everything is there in our mind. Let's go to the next one. X1 plus 2x2 equals to B1, 2x1 plus 4x2 equals to B2. Solution exist. Solution exist. What does that mean? This is what we need to write down. Solution exist. It could be zero solution or it could be infinity solution, whatever it is. Sorry, it could be it could be unique solution or it could be infinite solution. We don't care about it. Okay, we just care about this thing. The rank of A should be equal to rank of A augmented B. So let's make A augmented B. So if we make A augmented B, what we are getting? This will be just calculative. That's it. Nothing else. It will just take the calculation. 2, 4 equals to B2, 3, 7 equals to B3 and 3, 9. That will be equals to B4. So what operations you are going to apply? R2 is being replaced with R2 minus 2R1, right? R3 will be replaced with R3 minus 2R1 and R4 will be replaced with R4 minus 2R1. Zero zero B2 minus 2B1. Right? 1 2 0 0. So here I'm subtracting twice of it. So it will be B2 minus 2B1. Then thrice of it I am subtracting. So this will become 1 B3 minus 3B1. And then I am subtracting thrice of this. Thrice. This will become 3. And B4 minus 3B1. Is that clear? So now what I will do I have the page? Yes, I have the page. So next page only I need to take transformations I need to apply. What kind of transformations I will apply? So I will take it upward and I can see the transformation that this should go upward, no? Because here the first non-zero element is this one, here it is this one, and here it is this. So this one should go upward. And what I can do is that I can subtract thrice of this. Basically what I am doing is that in R4 I am subtracting R4 minus 3R3, right? R4 minus 3R3. And also I will put R3 and R2 I will interchange. So let's see what I am getting. So first one remains as it is 1 2 B1, right? Now this R3 and R2 are interchanged, so 0 1 B3 minus 2B1 we are getting here, and this is 0 0 B2 minus 2B1, and the last one thrice of this I am subtracting. So 0 thrice of this will be 0, and here what you will get at this place, what you are getting thrice of this, that will be B4 minus 3B1. Thrice of this I will subtract. So 3B3 minus 9B1. So what you are getting? B4 minus 3B3 plus 6B1. B4 minus 3B3, and this is minus 3B1 plus 9B1. So it will become 6B1. Okay. So this is the scenario that you are getting. So eventually, what is the scenario we are getting? Eventually, this is the scenario we are getting. B4 minus 3B3 plus 6B1. This is what we are getting. Understandable? Now, what do you want? You want rank of A should be equal to rank of A augmented B. You have already seen that rank of A is coming out to be 2. And you want it to be equal to rank of A augmented B. So in A augmented B, this is non-zero row. This is for sure non-zero row. You want them to be 0 row. What does that mean? B2 minus 2B1 should be equal to 0. And B4 minus 3B3 plus 6B1 should be equal to 0. So this is the answer. B2 should be equal to 2B1. B2 should be equal to 2B1. And 6B1 minus 3B3 plus B4 plus B4 should be equal to 0. So option C is correct. B2 should be equal to 2B1. B2 should be equal to 2B1 and 6B1 minus 3B3 plus B4. 6B1 minus 3B3 plus B4 should be equal to 0. Again, the same kind of question is there. No new concept. Just solve it in this manner. You will get the answer. Solve this question. Let P be a matrix whose columns are A, B, 3 minus B and A minus 3B. In that order, the number of linearly independent solution of the homogeneous equation Px equals to 0. Our equation is Px equals to 0. And what is our matrix P? This is our matrix P. What is the meaning of linearly independent solution? Number of linearly independent solution. That means number of free variables they are asking. What they are asking? Number of free variables they are asking. So how many number of free variables you will have? This is what they are asking. Okay. So what is our matrix P? This is our matrix P. That A is one of the vector 2, 3, 0. Then B is one of the vector 2, 0, 3. The next vector is 3A minus 2B. So 6 minus 4. Whatever it is, 3A minus 2B. Sorry, 3A minus B. So thrice of this will be 6. 6 minus 2 will be 4. Thrice of this will be 9. 9 minus. Thrice of this will be 0. Minus 3. And A minus 3B. A minus 3B. So A minus 3B. A minus 3B. So 6. So this will become minus 4. This is 0. A minus 3B. So this will become 3. And A minus 3B. This will become minus 9. A minus 3B. 6 minus 4. A minus 3B. 3. A minus 3B. Minus 9. 3A minus B. 6 minus 2. 9 minus 0. 0 minus 3. Yes. So this is our matrix P. Matrix P is A, B, 3A minus B, A minus 3B. What you need? You need to find out the number of free variables. What that would be equivalent to? That will be equivalent to the nullity of A. Right? Nullity of A will be what? Number of columns. How many columns are there? 4. Number of columns means this will be equal to the number of variables. Number of variables. So number of columns are 4 minus what? Rank of A. Now you need to find out the rank of A. Now you can find out the rank of A. But without even doing the calculation, I can tell rank of A will be 2. How? Without even doing the calculation, I can say that rank of A will be 2. How I can say so? This is column 1. This is column 2. This is column 3. And this is column 4. Can I say column 1 and column 2 are linearly independent? Are they depending on each other? Column 1 and column 2? No. And can I say column 3 is depending on column 1 and column 2? Because column 3 is nothing but 3A minus B. So column 3 is depending on thrice of column 1 minus column 2. And what is column 4? Column 4 is depending on column 1 and column 2. So what is column 4? Column 4 is nothing but C1 minus 3C2. So column 3 is also depending on column 1 and column 2, and column 4 is also depending on column 1 and column 2. So eventually C1 and C2 are linearly independent and C3 and C4 are linearly independent. So how many linearly independent columns you are having? We are having 2 linearly independent columns. What does that mean? That means that rank will be nothing but 2. There you go. 4 minus 2. What will be the answer? 2. This is the answer. These many independent solutions you will have. Independent solutions. How did we solve it? Did you understand this point or not? Matrix P I could have framed. This is the matrix P. Okay. I don't even need to frame it, but still I wrote down the matrix P. Px equals to 0. Right? What I need to find out? Number of linearly independent solution. That means number of independent solution, or you can say number of free variables I need to find. That will be coming out to that will come from nullity of A. Nullity of A would represent the number of free variables. That will be equal to the number of variables. How I can find out the number of variables? That will be equal to the column of vector A. Nullity of A or nullity of P. Okay. Nullity of P. Because here we are writing matrix P, right? Yeah. So this is a 4 cross 4 matrix. That means number of variables are 4. We need to find out the rank of P now. So how will I find out the rank of P? I know that there are 2 linearly independent columns and 2 linearly dependent columns. So there are only 2 linearly independent columns. That means the rank of P will be 2. So nullity is coming out to be 2. That means 2 independent solutions we will have. Is that clear or not? Very simple thing. Just by looking at this question, I will be able to write down the answer. I don't even need to use the pen. Px equals to 0 is the equation. Okay, homogeneous equation. I need to comment on P. So nullity of P I need to find out. Number of variables will be nullity of P. Nullity of P will be number of variables minus the rank of P. Number of variables do I have? Yes, sir. Number of variables will be equals to the columns of P. Why is that so? Because column of P should match with the number of variable. So that will be 4. 4 minus rank of P I need to find out. How will I find out the rank of P? So columns are A, B, 3A minus B, A minus 3B. That means the two columns are depending and two columns are linearly independent. So two columns are linearly independent. What does that mean? Rank will be 2. There you go. Okay, so 4 minus 2, answer is 2. Solve this question. Let A be a 6 cross 6 matrix. Find out the number of linearly independent solutions of a homogeneous equation Ax equals to 0. Again, what you are supposed to find out? What is the order here? 6 cross 6. What you are supposed to find out? Nullity of A. Nullity of A will be equals to the number of variables, that will be equals to 6 minus rank of A. What will be the rank of A? Rank of A will be 1. Simply you can see that row 2, row 3, row 4, row 5, row 6 all are depending. Or you can say column 1 is depending on column, so column 2 is depending on column 1. Column 3 is depending on column 1. Column 4 is depending on column 1. Column 5 is depending on. Basically all are same, no? It is pretty obvious. You can apply the row echelon form as well. You can get the row echelon form. What will be the row echelon form? That in R2 I am subtracting R2 minus R1. In R3 I am subtracting R3 minus R1. And so on. In R6 I am subtracting R6 minus R1. So what you will get? What you will get? This kind of scenario you will get that this will be a non-zero row. Rest all the rows will be 0. Rest 0, 0, 0 you will get. So only one non-zero row you will have. Only one non-zero row you will have. So only one non-zero row. What does that mean? 6 minus 1. What will be the number of independent solution? That will be 5. So in the examination it could be asked for b to the power n plus 1. Sorry, b to the power n. Here what they will write down? 1 plus b to the power 1 plus b to, sorry, 1 b to the power 2 b to the power 3 dot 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 b to the power n. Then the matrix will be n plus 1 cross n plus 1. What will be the number of independent solutions? So what you will say? N plus 1 nullity of A will be equals to number of variables, that will be n plus 1 minus rank of A. What will be rank of A? Rank of A will be only one line. So rank of A will be 1 only. So answer will be n. So n independent solution I will have. Where n is not this. Okay. N is not the order. N is this power. B to the power n. Okay. N is not the order. So let's not write down because people will get confused. So answer of this question is 5. Understandable? Let's solve this question. Ax plus y plus z, x plus by plus z, x plus y plus c equals to 0 having non-trivial solution. Non-trivial solution. What does that mean? Rank of A should be less than the number of variables 3. And A will be a 3 cross 3 matrix, which I can directly see. A will be a 3 cross 3 matrix having a rank of A less than 3. What does this represent? This is what it represents. So our target is making this equals to 0. A 1 1 1 B 1 1 1 C, that should be equated to 0. You need to find out the value of this one then. And A B C cannot be equals to 1. This is what you need to find out. 1 upon 1 minus A I need to get, no? And then plus as well. So let's solve it. What we will get? A into BC minus 1 minus 1 into C minus 1 plus 1 into 1 minus B. This is what we are getting. So ABC minus A minus C plus 1 minus B equals to, so ABC minus A plus B plus C plus 2 equals to 0. Let me check the calculation. A into BC minus 1, then minus 1, then C minus 1, then plus 1, 1 minus B. So ABC minus A minus C plus 1 minus B. So ABC minus A plus B plus C plus 2 equals to 0. You need to make this particular thing. Now if this question is coming in NAT, okay, let's just say this question is coming in NAT. If it is coming in NAT, You need to find out the value of 1 upon 1 minus a plus 1 upon 1 minus b, and this is the condition you have got now. If it is coming in NAT, you know that answer will be some numerical value. Some numerical value will be the answer. So on your own, you can put the value of a. Basically, this is the condition I have got. ABC minus a plus b plus c plus 2 equals to 0. And you need to find out the value of this thing. And one thing I know that the answer will be a numerical value. Answer will be a numerical value. So no matter whatever the value of ABC you put, this condition should be satisfied. If this condition is being satisfied, then it will give you a numerical value. Let's just say what I mean to say. Here they have said that A, B and C cannot be equals to 1. So I am saying that I am taking A as minus 1 and B as 2. Let's see what value of C I get. What value of C I get. So if I put A equals to minus 1, B equals to 2, so this will be minus 2C minus 1 plus C plus 2. So minus 2C minus 1 minus C plus 2 equals to 0. C is coming out to be minus 1 by 3. And these are the values of AB you have taken. So if you take A equals to minus 1, B equals to 2 and C equals to minus 1 by 3, then this condition is being satisfied. And this is what we are getting, that this condition needs to be satisfied. Now if you put these values here, what answer you are getting? Plus value of B I have taken as 2. Value of B I have taken as 2. Plus value of C I have taken as, value of C is coming out to be this. So this is coming out to be 1 by 2 minus 1 plus 3 by 4. Some calculation mistake. Minus 2C minus this is becoming minus 3C. Yeah, A is coming out to be 1 by 3. C is coming out to be 1 by 3. So this will be minus 1 by 3. So this will become 2 by 3. So 3 by 2. So this is minus 1 by 2. Minus 1 by 2 plus 3. Answer is 1. So what is the answer we are getting? Answer is 1 answer we are getting. That's it. Numerical answer. Did you understand what I did here? Look, I know that this determinant I need to put equals to 0. When I am putting this determinant equals to 0, this is the condition I am getting. Now I need to find out the value of this one. I don't know how I go from here to here. I don't know how do I go. I don't know that. So what did I do? I pick up some random value, no, because answer will be some numerical answer type. Numerical value I will get. That I am pretty sure, no, because it is coming in NAT. So numerical value I will get. So what I did? I put the value of A equals to minus 1, B equals to 2, and C, I put a variable. Why I put C as a variable? This kind of question we have solved some in basics of matrix and determinant as well. One of the variable I will put, one of the variable I will put, when I put all these values in this equation, I get the value of variable as 1 by 3. That means if A is minus 1, B equals to 2 and C equals to 1 by 3. If A is minus 1, B equals to 2 and C equals to 1 by 3, then this will become out to be 0. So these values of A, B, C are acceptable. So can I put value of A, B, C here? If I put the value of A, B, C here, what is the value of this particular function I am getting? That is 1. That's the answer. That's it. Is that clear to you? Say yes or no. Who knows, it may come in MCQ as well. So in MCQ as well, this is how you can check. Put the values and then check it. Okay, build up the enough practice, you will be able to solve it. No doubt at all. Well and good. So value is coming out to be 1. It was not a tough question. It's just that how we will solve in the examination hall. So this is the condition we are getting. Now we don't know how to go from here to here. Then what we thought, this will be a numerical value. So I need to get a numerical answer. So what I did was, I put a random value of A, put a random value of B, then find out the value of C. That means ABC will satisfy this equation. Now those ABC value I will put in this equation and I will get my answer. Let's go to the next question. One question is left, then 2 and then 3. 3 questions are left. Yeah, try solving this question. A be a n cross n real matrix such that a square equals to I and y be a n dimensional vector. The system of equation ax equals to y has no solution, unique solution, infinitely many solution, cannot be determined. What is given? A square equals to I is given. What does that mean? A dot A equals to I. If I say A dot B equals to I, what does that mean? That means that B equals to A inverse. They are saying A dot A equals to I. What does that mean? A equals to A inverse. From here, what you can understand that A inverse exists. A inverse exists. What does that mean? This is not equals to 0. What does that mean? Rank of A is equals to the order n. This is what it means. Right? And if rank of A is n, did you understand? A square equals to I was given, A into A I, B is A inverses, then A will be A inverse. That means A inverse exists. If A inverse exists, that means determinant of A will not be equals to 0. If determinant of A is not equals to 0, that means it is a full rank matrix. It is a full rank matrix. That means rank of A is nothing but n. If rank of A is n, what do you understand from that? That rank of A is n. Let me know one thing. If rank of A is n, then what will be the rank of A augmented y? You know one thing for sure, that rank of A has to be less than or equals to rank of A augmented B. But here it is y. And rank of A augmented y can never be greater than n. Has to be less than equals to n. Why is that so? Think of it, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, and here alpha, beta, gamma. This is your matrix A. This is your matrix B. So rank of matrix A is coming out to be 3. What could be the maximum rank of A augmented B? This is a 3 row and 4 column. So what could be the maximum rank? That will be 3 only, no? So it will be surely less than equals to n. Now you are saying that rank of A augmented y, rank of A is what? N. So from here what you are getting? And from here what you are getting? If you combine both of them, if you combine these two guys, then this is the condition you are getting. Rank of A would surely be less than rank of A augmented y. Now rank of A augmented y would surely be less than n, less than or equals to n, right? That means what you are getting is that rank of A augmented y is either greater than n or less than n. Greater than or equals to n or less than equals to n. What does that mean? It has to be equals to n only, and that is equals to rank of A. And it is pretty obvious. Rank of A is n. If rank of A is n, then surely rank of A augmented B will also be n only, no? Because rank of A is n. That means this is also non-zero row, this is also non-zero row, this is also non-zero row. So all three are non-zero row only. So all these things you don't even need to do. If rank of A is n, then it is pretty obvious that this is non-zero row, this is non-zero row, and this is non-zero row. So rank of A augmented y will also be n only. And both are same, and they are equals to the number of variables. Why number of variables? Because what this represent? Number of variables. So that is equals to number of variables. What does that mean? That means it will have unique solution. This is how I need to think. The information was given that A inverse is existing. If A inverse is existing, that means the determinant of A is not equals to 0. That means it is a full rank matrix. Rank of A is n. Rank of A is n, then surely rank of A augmented y is also n. Both are equal. That means unique solution. There you. Next question. Vector x1, x2, x3 all are linearly dependent. Okay. Vector x1, x2, x3 are linearly dependent. And A is the coefficient matrix of homogeneous equation whose columns are x1, x2, x3, x4. So A is a, here x1, x2, x3 are not variables. Okay, they are not variable. They are not variable. They are the column. Okay, they are the columns. So don't get confused that sir x is x1, x2, x3. No. Just for your confusion, it is given x is a variable. It could be anything. X this variable could be x, y, z, q. Anything. The variables could be anything. x1, x2, x3, x4 are columns. Okay, so this is your matrix A. This is your matrix A. Okay, this is your matrix A, where the column is x1, x2, x3, x4. And they are saying that they are linearly dependent. What does that mean? That means rank of A is surely less than 4. or they did not give the length here, then basically they are dependent. No, they are dependent. They are depending on each other. Are you able to understand this point? X1, X2, X3, X4 are depending on each other. That means there are maximum 3 linearly independent vectors. Maximum 3 linearly independent. They are depending, no? That means maximum 3 linearly independent vector could be there. That means rank of A is less than 4, which is less than the number of variables. Basically, it is not a full rank matrix. No, it is not a full rank matrix. A is not a full rank matrix. Not full rank matrix. If A is not full rank matrix, what does that mean? That means what kind of equation it is? Homogeneous equation it is. So either it can have unique solution or it can have infinite solution. For unique solution, it has to be equals to n. But what it is coming out to be? It is coming out to be less than n. So this was the condition of unique solution, and this was the condition of infinite solution. So it is coming out to be less than n. What does that mean? That means there will be infinitely many solutions. The same question, but this time Ax equals to b. Understandable? So what will be the answer? It will have no solutions, infinitely many solution, unique solution, or only zero solution. Think about it. Pause the video and think about it. I will drink some water and then I will tell the solution. Yeah, welcome back. So in this question, we will do a slight modification. If the vectors x1, x2, x3, so these vectors are having dimension 4. Okay, what is the dimension of these vector? Dimension of these vector is 4. What is the meaning of dimension 4? That means x1 could be somewhat like this. At 1, 2, 3, 4. And transpose, because they will be column vectors, no? So that's why basically they should be somewhat like this. That x1 would be 1, 2, 3, 4. This would be your x1. Okay, so dimension is 4. I cap, j cap, k cap, l cap. So 4 dimension is 4. So if the vectors x1, x2, x3, x4 having dimension 4 are linearly dependent and A is the coefficient matrix of a non-homogeneous equation Ax equals to B, whose columns are x1, x2, x3, x4, then the system may have what kind of solutions your system may have. This is what they are asking. It can have no solutions or it can have infinitely many solutions. What it can have. So this is what they are asking. So what will be your matrix A? Your matrix A would be somewhat like this. X1, X2, X3, X4 and 4 element. 4 element. 4 cross 4 is the order. So from here I can find out the number of variables. Number of variables are 4. The similar thing should have been written here as well. The dimension should have been written. Dimension is 4. Okay. So here number of variables would have been 4. What they are saying? That they are linearly dependent. What does that mean? That means rank of A has to be less than 4. Let's just say rank of A is, it has to be less than 4. Let's just say rank of A is 3. What about the rank of A augmented B? Rank of A augmented B. So A augmented B will look somewhat like this. Some value, 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 and then some value. Let's just say these values are A, B, C, D. So it might happen that, let's just say it might happen rank of A is 3. That means this will be this will be 0 row. But it might happen that D is non-zero. So rank of A augmented B could be 4. It is possible, no? This D is non-zero. Last row is 0. I am saying rank of A is 3. But D is non-zero. So rank of A augmented B could be 4. So this is the condition of no solution. So yes, it may be possible that there would be no solution. But who knows? If D is 0, then who knows? Rank of A could be equal to rank of 3. Rank of A would be 3. Already 3 I am saying. And rank of A augmented B could also be 3. So this will be the condition of infinite solution. So answer could be infinitely many solutions. But one solution is not possible. Unique solution is not possible. Why unique solution is not possible? Because they are linearly dependent. If they are linearly dependent, then rank is lesser than 4. Right? And if rank is less than 4, what does that mean? Rank is less than the number of variables. Here also I said that rank is less than 4, but how you can say it is less than the number of variables? Can we say it? Yes, we can say it. Dimension is not necessary because what is the number of columns? Number of columns are 4 only, no? Number of columns, like I don't know what is the number of rows, but number of columns are 4. That's for sure. So rank is less than the number of variables. Yes, I can say rank is less than the number of variables. So dimension equals to 4 is not necessary here. Because number of variables are 4. So rank is less than the number of variables, then there will be infinitely many solution. And here dimension is necessary or not? Rank is less than 4 because they are linearly dependent. So rank is less than 4. So even if the dimension is not mentioned, then also it is fine. Even if the dimension of a vector is not mentioned, then also it is fine because I just need the number of columns. This is telling the number of variables. So I don't need this number. Say yes or no. I only need the number of columns. So even if this dimension was not mentioned, then also it was fine. So what you understood here, that it might happen that infinitely many solutions are there, or it might happen that there is no solution. Unique solution is not possible. Can this ever be possible? What I am saying is that I am asking you a question. What question I am asking you? That your equation is non-homogeneous linear equation Ax equals to b. Can this equation have 0 solutions? Can this equation have 0 solution? 0 solution means x1 equals to 0, x2 equals to 0, x3 equals to 0. Is this possible? It is a non-homogeneous equation. What it is? It is a non-homogeneous equation. Non-homogeneous equation. So for non-homogeneous equation, 0 solutions are possible or not? This is what we are asking. So can we write down some non-homogeneous equation? Let's just say I have written 2x1 plus 3x2 plus 4x3 equals to 7. 2x1 plus 4x2 plus 3x3 equals to 0. Minus 4x1 plus 2x2 plus x3 equals to 0. I want this to be the solution. So equation 1, 2 and 3. This solution will satisfy this equation 2. This solution will satisfy equation 3 as well. But this can never satisfy equation 1. First let me know, is it a non-homogeneous equation? Is it a set of, or is it a system of non-homogeneous linear equation? Yes sir. It is a system of non-homogeneous linear equation. If it is a system of non-homogeneous linear equation, then can this be solution? Sir, you put 0, 0, 0 here, 0 satisfied, 0, 0, 0 satisfied. But 0, 0, 0, one element will be surely non-zero, no? So it can never be a solution. What does that mean? That non-homogeneous system of non-homogeneous linear equation. Non-homogeneous linear equation can never have 0 solution. Please notice that 0 solution does not mean no solution. 0 solution does not mean no solution. What is the meaning of 0 solution? 0 solution simply means the solution vector is 0. And what is the meaning of no solution? No solution means no solution only. No value of this x not even possible. X is not even possible. So both are different thing. Both are complete different thing. Okay. So one statement could be written: the system of non-homogeneous linear equation can never have 0 solution. Yes, this statement is true. I hope you have understood a lot of things in this lecture. So here the lecture would end. Okay. Thank you very much. In the next video, we are going to study about vectors. Whatever that we have studied, the similar scenario would be there. It is just that a complete different way would be there. That's it. Again, whatever that we have studied already, the similar thing we are going to study, just some notation would come up. So concept is very less. Concept is very less, but problem solving will be more. So here as well, there was concept was very less. Started with this concept was very less, but problem solving was more. Okay, this much was the concept. But after that, a lot of problems we solved. Okay. So let's meet in the next lecture. Thank you very much. And you comment down, how did you feel? How did you feel studying this topic? If you are studying it for the second time, if you have already studied it from somewhere else, then you would realize the difference. Okay, what difference we have created. Yeah, so please comment down if you found it helpful. Yeah, thank you very much.